the names of the cities and their populations. And I was wondering how well they were doing. I've done this previously with SQLite and Postgres and got some very good results. So I went out to Grok and I said that prompt. And as you see at the top, it says to find all the cities in the Texas district and their populations from that database. You can query the city table by filtering the district column for Texas. And they give you the explanation, they give you the query, and they give an explanation. So if you're learning SQL, this is a great way to learn how to assemble a query. If you were a senior programmer, you had a junior programmer came for this query, you'd be fairly happy with it. So that was the first one. Next one was Google. Its output's a little bit shorter, and it basically gives you a smaller explanation. And it does something a little bit differently. It says, let's identify the country code for the United States and then filter the city table based on that country code and the Texas district. So it knows that Texas is in the US, and therefore you have to search for the US in Texas. Ollama, which is a little different in that you self-host it, or you can self-host it, most people do. As you can see, it has more of an old CLI type interface, and I put in the prompt up here, and it comes back with pretty much the explanation of the same thing with the query. It says select city population, has a comment. This specifies the columns what's to retrieve. Pretty much the same as the first one from Grok, and I thought it was, a good solid B plus A minus answer. ChatGPT is interesting. One of the problems I have with ChatGPT using Postgres is it doesn't know any version of Postgres past Postgres 14. We're now on Postgres 19, or 18 going on 19. So I was very relieved to see it gave a nice explanation saying to get all the cities in Texas and populations, you need to only read the city table. And it gives the columns. And the explanation down there talks you through why it picked the certain columns. Now, as you noticed, all of them had a core query. The select up to the where statement is all the same, which, very simple query, you'd expect that. Where they vary is that Grok, ChatGPT, and Ollama all just stop there and say district equals Texas. And as I mentioned earlier, Google wants to be a little especially refined because they want to make sure that you're also getting everything from the country of the United States. So that way we won't be fooled if Mexico suddenly decides to have a district called Texas again. So my conclusions for this one was that previous example used a well-known database to feed to the LLM, and it gave a fairly good, predictable answer, did a good journeyman job. The responses were all pretty consistent, all produced good SQL that did the job. Now, the trouble is, well-known database that's been out there for 30 years, it's kind of hard not to know how to do that. It's like the recipe for ice. Even I can find that on Google these days. So, second example, write SQL to create a table on a MySQL 8.0, specifying the database and the version, to store customer data. And then I specify the data, a first name, a last name, an address, a birth date, and ask it to use a UUID primary key. Some of you longtime MySQLers are kind of saying, ooh, UUID and 8.0 might be an impedance mismatch there. Then I say partition the data by the year of birth and produce test data of at least 10 records. By the way, if you're a fan of Dilbert and you recognize this character, I've seen dozens of companies that have someone who's an SQL coder who gets asked to write queries like this on a regular time from a pointy-haired boss. So that's one comment. So to do this, I also had some goals. I did not want to write any SQL. No SQL, not no SQL, but no space SQL. I want to do absolutely no coding if possible. And I also used the dbeaver AI explain and fix to correct issues with this. And you'll see why in a minute. By the way, the AI explain and fix, if you haven't tried this yet, come by the booth, I'll give you a full demo. This is really cool. It opens an AI chat takes your query and your error message and said, something syntactically is wrong here, tell me what it is. And for the following examples, I'm using OpenAI with the GPT-4 model. Your mileage may vary depending on what you're using. So once again, come by the booth for a demo and we'll be happy to accommodate you. A quick example of how it works. I have a query where I'm selecting customer ID, name, and last name from a table. And I get the error message, there's an unknown column name. I put in name instead of first name for the second column that I'm asking for. So I feed all this into the AI by using the explain and fix button, and it comes back with an explanation saying, the error message indicates that there's no column named name in the customer's table. You should use first name instead of name. Here's the correct query. You copy that query onto the stage and run it, and you get your results. So it's a quick way to double check what you're doing. So what do they do? Well, as I mentioned earlier, I was a little disappointed. Works much better with fairly standard versions of Postgres and SQL Server. Does fairly well with MS SQL Server. But MySQL kind of shocked me that it wasn't quite there. Grok came up with this, where it's basically, you have a table named customers. Remember, I wanted the ID to be a UUID. So it carves out a 36-bit car column. First name and last name are varchar 100s. Address is a varchar 255, and birth date start is a date. Notice that they're all not null. Bonus points for there. And it sets up the primary key as the ID and the birthday. And it also says you can optionally index if you frequently search by name and how to do it. And then it has partitions. Partitions pay attention to in the next couple of examples because they're kind of weird. What they did is they went for earlier 1970, the 1980s, 90s, 2020, the 2030s, which we haven't come up yet, so it's kind of planning for the future, and then anything past that. And then you see that it has test data. If you're a Texan, you'll be happy to note that they used a wide variety of Texan addresses. I don't know if it's left over from the World Database, but we have Austin, Dallas, San Antonio, Fort Worth, Plano, Arlington, and others. So you go to run this, and here's another alternative way to load the data to get the UUID. So you go to run this, and you get an error. The error message indicates that there's a syntax error near engine equals NODB, row format equals dynamic, default car set, UTF-8 MB4. And you send that off through the AI, and it comes back, and it corrects your code. You notice that basically we're moving the chunk down here to there. Google Gemini. Very interesting that they have a 16-bit binary ID. They've changed the varchar down to a varchar 50. The address is still a varchar 255, and birth date is still a date. And then the partitioning is kind of odd. 2010, 2011, 2012, 2013. I guess they're expecting a bunch of young people to be using this instead of us old geezers. The data that it has, it actually has a call to a unhex replace UUID to get the ID number. The cities are any town, other town, some town, Townsville. So good data. Now when you go to run this, it comes back and says the partitioning function is based on birth date, but the column is not included in the primary key, and you have to do that. So you ask it to fix it, and it changes the primary key over to ID and birth date. By the way, if you have questions, please let me have them. Okay, Olama, the one self-hosted. This was interesting in that the customer ID is now your UUID marked as a primary key with a default UUID function call. First name and last name are the varchar 255s, as is the address. Birth date is a date, and birth year is a use for partitioning, and it has an index set up on it. Now, anyone here who hasn't had a cup of coffee, I ask you to explain this partitioning sequence over here. I looked at that for a good 10 minutes when I first saw it and could not make heads or tails of it. It's one of those things where it's an obvious blunder by the AI. Once again, in the test data, we have a bunch of people from any town, USA. When you go to run this, there's a problem with the UUID data type and its default value. MySQL does not support UUID data type. Instead, you should use char 36. So, made an assumption. And when you correct everything, that's what it looks like. Notice the partitions are 2002, 2006, 2011, 2016, and 2021. A little different than using every year or by going by decade. And what was also interesting is I tried to put in the data, and it caught it that there wasn't a default value for the ID field. So we had to go back and fix that. It wasn't set up as an auto increment. Okay, the last one, ChatGPT. This one, once again, customer ID is a car 36. First name is back down to a var car 50. Last name is also 50. Address still says 255. Birth date is a date, and notice it uses a generated column to come up for the year, for the birth year, and then it's doing the primary key on that generated column of birth year and customer ID. Partitions are decades starting in the 60s, running through the 2020s. Thought that was interesting. Also interesting was that they actually used Texas cities for the cities. When I ran this, go through there, the provided snippet seems to be part of a create table statement, but the beginning of the statement is missing. Primary key and partition by cause should be part of the create table. So when you run it through the AI fix, it comes back with this, and it's a little bit changed, but not all that much. But it does do something weird. It creates a customer partition table. So this is a thing where if a junior programmer handed this to you, you take them aside with a whiteboard and you explain how you don't want to do that. So 2 out of the 4 kind of did B- work. The other 2 kind of you need to be watching. To compare them all, IDs ended up being either 36-bit chars or binary 16. Names ranged from varchar 50s to 255s. They were all listed as not null, which is good for keeping your data clean. Birth date were all date fields, and primary keys all eventually ended up being the ID and the birth year. So, and the other thing is I want to mention is the approaches to partitioning. Grok had 8 by decades, Google had 13 by year, 5 partitions for Llama, and 8 by decade for ChatGPT. So if you're a teacher at a community college in Arizona and you handed out this assignment and these students handed it back, you understand that they understood the concept. They may not be great on the execution, but the students at least have a grip on how things are working. So the conclusion, when creating a new table by an LLM right now, it's kind of a mixed bag with MySQL. All 4 LLMs, as I mentioned earlier, do better with other databases. The partitioning schemes are kind of dramatically wild from each other. If this was a team competition, you'd probably want to sit down and hash out which one you'd want to stick with. They're all workable to a certain degree other than doing it by year. And also, you'd probably want to have a good discussion on how big is a name or an address. Oops. So, the company I work for now, dbeaver, is a tool for working with multiple databases. It has several great features, including its built-in AI assistant. Now, our competition also has similar AI assistants, and I'm going to talk about dbeavers just because I work for them, and I'm much more familiar with them. But if you want to talk about JetBrains or someone else's product, I can do that. The way dbeaver's product worked is before you send data to an AI, you have to confirm that you know that you're sending data to the AI, because you might have something that's company sensitive or classified or highly privileged. You don't want going down that great party line that is the internet. In that case, you might want to use something like Olama for your LLM to hold your data. Also, with dbeaver, you have the option to send your keys, primary keys, unique keys, to the LLM to help it determine what it can do. Also, you can send sample data. You don't have to send any data at all, but you can use it to send sample data. So if you want to create a query and all it knows is the metadata, the table definition, you're safe there. Also, you can exclude what tables to use and exclude others. Now, the default is to only send metadata, and you have to decide whether you want to send anything else. And what's really handy is I think now we support 7 LLMs in the Pro version and 5 in the community version. I think that's right. Yeah. And once again, you control your data. Before you send anything over, you have to say yes or no. In this case, I'm trying to use the MySQL SCaLE database, and it asks me, do you confirm AI usage for this table? If you have something that is highly classified or even sensitive, do not send it over without checking with your security folks. Now, one of the interesting things about our product is that you can type &AI and type a question into the AI that will be turned into SQL. By the way, we support like 12 languages, French, German, Spanish, Basque, and several others. And here I just typed AI, who are the top 5 customers and how much revenue do they generate? Now, if you're the data guy and your head of marketing comes in and says, hey, give me this information, you're going to spend a lot of time going out to that table, trying to figure out all the things, all the columns you need to gather to be able to put that into a query. But the good thing here is that you put in your prompt, it will generate the SQL for you, and you'll see the results faster than you're going to go out there and look at the various columns. Also, there's another feature we have is that you can describe the SQL you want. The last one I said the AI, give me the top 5 customers. In this one, I'm typing -- which is a comment, space, top 5 cities for revenue, and I type in select because I want to use the select statement. And then I hit Control-Alt right arrow, and it will generate the SQL for me. So for those of you who are busy and you don't want to dig through the DDL for your tables, this is a fast way to do stuff. And we even have a pretty printer, so if you want to clean up what you see on the left, that will do that for you too. One of the problems that I always had where I worked is that we always had these projects that I called thrown over the wall projects. Hey, so-and-so down in receiving came up with this database that's running on you're smiling because I can tell you've suffered through this. He's off on vacation, but we need to do this to keep the business running. Could you take this spreadsheet and turn it into a database, or take this DBase2 file and turn it into something we can use? Yeah. If you haven't had the pleasure of this, it's terrifying. So one of the things that dbeaver can do for you is you can ask it, at the bottom there in the red arrow, describe the database object. And in this case, we have a new database, and it's our dbeaver's example database. And I say, well, tell me about this database. And it comes back and says, database schema consists of several interconnected tables that store information about a music store. You young folks, we used to have to go to stores to buy our music. You just couldn't download it. You actually had to go someplace and go through these things called records and read through them to find the one cut on the album that you wanted to buy. You just couldn't pick the one you want. The album table holds information about music albums, including an album ID. Track table contains details. So this is a handy tool to figure out, you have this new schema, what does it actually do for me? Also works with tables. I've always been lucky that I've inherited wonderful tables that were done by someone who was at the prime of what they were doing and knew they were out the door soon, and the tables were not always exactly relevant. So here I'm asking for a description of the table called artist. The artist table's database schema is a key entity that stores information about various artists. It has two columns, artist ID, which is an integer and serves as the primary key, and name, which is a variable character field that holds the name of the artist. So not only is this great for elucidating what's going on with what you find, documentation. How many here people love doing documentation? Yeah, someone aren't. Another thing is occasionally someone will hand you a query and say, we have no idea what this does. It used to work. And the guy that has it is off with a broken back in the hospital for the next 6 months. Could you take a look at it? So in this case, we have this query, and I'm asking it, what does this query do? And I put in the query, which is select c.firstname, c.lastname, count distinct, And rather than going line by line and join by join, as you can see here, there's, 4 joins. I can ask the AI what it does. And it says, this query is designed to retrieve information about the top 5 customers who have rented films from the most distinct categories and have the highest total spending. Now, where this also was handy is you could come in here and ask the AI to expand this query. Okay, only cover California, Arizona, and Nevada. Boom, it'll change the query for you. Here's another one where I'm changing a query on the fly. I have this similar query as the last one. I say in the prompt, please list by state and list the revenue. It will correct that query for me, and away it goes. Very handy, very smooth. Query Builder. This is also something that's very handy. I'm an old timer. I grew up in the age of Fortran, COBOL, and the early days of C, and having to design code with drag and drop was something that happened well after my educational experience had ended. For dbeaver, what you can do is you open up a window and you click that thing to the right arrow where it says Builder. And then from there, you drag and drop the tables you want. In this case, I've dragged and dropped the customer table, the stores table, and the rental table. And you notice these blocks in between the various tables up there. You can change the join. So if you want a left join, a right join, you can adjust that. And then as you notice down here, as I drop stuff in there, it's already setting up the basic part of the query on what joins where. And from there, I can select by clicking boxes on each of the tables what columns I want. So if I want return date, I click on there, and it automatically adds that to the query. Very handy. So the big premise of this was talking to a lot of DBAs and professional database professionals and folks who manage data for a living. You know, is this a step forward? Because AI has been overhyped. And this is one of those things where you play with the dbeaver product and you find out how valuable it is because it saves you time and effort and from digging a lot of stuff. And for quick and dirties, it's absolutely amazing. And for the more complex queries, it can get you started on the right foot. So do you need an AI assistant? Well, I'm making the case for that. So please give it a try. I think it's like going from VI or Emacs into an IDE. It's going to be the thing where you're used to having keyword completion. Now you're going to have query completion pop up for you, so you'll be that one more step ahead. So what do you get when you do this? Well, it can write queries for you. It can do it in multiple languages. It can explain the structures of queries or data for you. It can augment making queries, doing it a lot faster. You can probably do it by yourself. And the great thing is you can do as much with it or as little as you need. If you never want to write SQL again, we're there. If you love writing SQL but need someone to look over your shoulder trying to figure out what that one syntax error is, it will do it for you. One of the things I have is I look at our trouble tickets every morning, and we have a bunch of labels to classify. Is it a Postgres error? Is it a UI error? Is it something with the Java that we're embedding and stuff on? And those are all in one big string. And I say, okay, find me the label that says MySQL and tell me all the last entries on that. It does it for me. I don't have to remember how to go out in Postgres and break down a string and chop it up and bring it back piecemeal. It will do that for me. So, questions, answers, comments, complaints, what do you all have? Yes, sir. Mm-hmm. Let me point out Scott in the back, who is on the MySQL community team where I used to be. Will MySQL go away? No. I think the last two things we turn off in this world will be a COBOL application and a MySQL 5.7 database, in that order. I don't think it's going away. Oracle is appearing to steer away from future development of a lot of the neat stuff they used to do for MySQL, but they've been making noises this week. They had a, 2.5-hour webinar talking about how they're going to bring some stuff from the paid versions of MySQL into the community versions. So, knock on wood, we get another good 15 years of stewardship out of Oracle. Reality is, right now, there's a lot of folks who are very confused and don't know which way to leap. I have a blog I can show you later where I broke down what the various options are, including, don't do anything because it will still run, to changing databases, changing vendors, maybe let's just let the cloud providers run everything for you. But you do have options out there, but MySQL going away, no. I can actually find parts for my neighbor's Studebaker car online. They're not as common as they used to be, but they're still out there. Yes, sir. Well, I'm lucky in that the pro versions of dbeaver support nearly 190 different databases, including all the ones you mentioned. Our community edition, I think, doesn't support NoSQL databases or graph databases, but if it has an ODBC connector, we can talk to it. So I'm lucky in that I have a tool that lets me talk to just about every database out there. So, yes, sir.
Is what you showed possible with the community edition for somebody to experiment with?
Yes. Drop by the booth. I have enterprise and community on my machine. You can play with both. You're a little more limited to, I think, Google Gemini. I'll tell you what. My mouse working. The funny thing, come by the booth, we'll talk about pricing. It's kind of embarrassing because we're really low cost. And by the way, this is 26.0, the version that just came out. Let me download a driver real quick. So if I want to use the community edition, here we go, OpenAI and GitHub Copilot, I'm sorry. The enterprise version has a much richer set. This is one of the things where if you're paying for a big bill on an LLM, we're not going to be your biggest cost. Here, let me try the Enterprise Edition. Can't lock because I have two editions running. And we are adding more LLMs in the future. I just don't know where. I can't mention what. No, that's, hold on, let me get rid of the Community Edition. Okay. Enterprise Edition, this is Enterprise Edition, and We have Amazon Bedrock, Anthropic Claude, OpenAI, Copilot, Gemini, Ollama, and OpenAI. So depending on what you want to play with. If you're starting out, try the Enterprise and see what you like. And then, by the way, you get a free 2-week trial of any of our Pro versions if you're interested. And drop by the booth, we'll let you play with it. Any other questions? Yes, Scott?
Not a question, but just an observation. I've been doing a lot of work with AI in database work with personal observation I have. And I find it interesting that you seem to have similar issues with creating tables using AI and it's not getting the syntax correct or possibly not getting the data transfer correct. But if it already has the schema, it's amazing at generating again.
Yeah.
But it seems to be much better at getting the data than creating a smooth responsibility.
Yeah. So if for the recording, Scott was reiterating that AI's generating tables from scratch is kind of rough right now, but if you already have the tables out there, it does a lot better generating stuff from that. So. You're shaking your head. Have you done any of this stuff with AI? And what are your feelings about having an AI assistant?
Like you already have the tables and you ask for a query or something, it generates it. What would take an hour, take minutes.
Yeah.
It's so much faster.
Okay. And these are your 3 generative selves that you've trained? Yeah.
You guys I pass it on to, my sons, yeah.
Well, congratulations. You are entering a very interesting world. Any other questions, comments, concerns, or? Well, let me go back. If you're a speaker, if you're one of these people, we have Scott back there and Matthias. We have Phil. Any of the speakers here that I'm unfortunately not recognizing? Igor, right? Igor? Matter of fact, he's next. So watch out for Gabriel, and that's it. And with that, we've kicked off 23X. If any other questions, I'll be here for a little bit. I and Shannon, who's our head of marketing, will be over in the booth. And she's got the official dBeaver outfit. Big fan. And by the way, if you haven't tried dBeaver, it's the only product I've ever repped where people just come up and rave about it. And the complaints are usually feature requests, not, oh my God, you guys screwed up everything. It's a lot easier than working for MySQL or for Kona. And with that, no other questions. Thank you all for attending. Hope you have a great day.
Sound check. Sound check. Sound check. Nice.
Okay, hello. Can you guys hear me? How are you guys? So I will make sure to make this as smooth as possible. I'm happy to be here with you guys at the SCaLE 23X. It's very nice to see you all here. My name is Shannon. I will be introducing you guys to Igor Donchovsky. He is from Planet SCaLE, and he will be talking to us about Vitess for Newbies, and it's scaling with MySQL the YouTube way. If you have any questions or anything that you want to talk about, you can go ahead and let me know. We can go ahead and do that afterwards. But let's give a round of applause to Igor Donchovsky.
Thank you. Good morning, everyone. This talk is about Vitess for Newbies, scaling MySQL the YouTube way. My name is Igor, and I come as enterprise customer engineer at Planet SCaLE. I have a little bit more than 20 years IT experience, primarily working with databases for the last 15 years, primarily MySQL and MongoDB, and few years also with Postgres SQL. On a personal note, husband and father, traveler, speaking at conferences, and I have addiction to play these LinkedIn puzzle games every single day. I don't know if anyone else is doing that. So on today's agenda, the talk is about MySQL. So what are the MySQL limits? How do we do disaster recovery for MySQL, horizontal or vertical scaling, query management, online DDL, high availability, and how all this fits inside Vitess. Starting with MySQL and what are some of the limits that you may hit. So even if you are running your database on a single server, and let's assume that single server is with 100% uptime, that you don't need to restart that server for any time, you don't need to apply any patches, there is no hardware crash, you will still hit some limits when your database grows. Those limits are that you cannot grow a single server beyond, as of today, 32 terabytes RAM memory. You can have up to 8-socket CPU, each with 144 cores per socket. And this server alone will cost you nearly $500,000 without any storage. So the storage is on top of that price. If you are hosting this in a cloud provider, then you have to also think that you will be paying for bandwidth and maybe other maintenance tasks. The MySQL server itself doesn't have a limit on the database size. So in theory, the database size can grow indefinitely. However, there is a limit on the table space size, and a single table space size can grow up to 64 terabytes with the default 16 kilobytes page size in MySQL, and that is a limit that you can hit if you have a single table unpartitioned. The MySQL server has a limit of 100,000 connections, so that's a hard limit. From my personal experience, I have not seen any MySQL server that's running close to this limit, but also at the same time, MySQL cannot handle 100,000 threads running unless there is some thread pooling or a proxy in front of the server. If we speak about how many rows you can store in a single table that is using big integer as a primary key, that is something like 18 quintillion rows, which should allow you to generate auto increments for centuries. The query management in MySQL is improving version over version. So we have some of the things as listed here. For example, you can set a query timeout in MySQL, and the query will die if the engine doesn't respond in 5 seconds, for example. You can also use optimizer hints. So you can tell the optimizer, this is the index that I want you to use for this query plan. One thing that's lacking today in MySQL is that if you are running a query that doesn't have where condition, actually doesn't have a limit on the rows returned, you may saturate your bandwidth and just select star from a table will potentially have a big impact on your application, but there is option to fix this by just limiting the server response. So n number of rows will be streamed, even if you run just select star from users, for example. And also another thing that you will need to plan in your application if you're using just plain MySQL. If you run the same query, like select star from videos where video ID equal 1, that query, if it's run 100,000 times, every single time it will run inside MySQL. So the application should be smart enough to run the query once, and if there are a bunch of requests coming at the same time, then the same result should be returned to the application. Another thing that is improving inside MySQL is running DDL. MySQL is evolving, and instant DDL is now a feature that, for example, if you want to add a column in MySQL, that operation will be instant. However, some operations are still not instant, and even with instant, you still have to do metadata lock. For other things like adding a secondary index, you will be locking the entire table, and that operation is also resource greedy. So if you run it on a single MySQL instance, it will use all of the resources on the server, and that's just for a single server. It's not revertible. If you run alter table, then you cannot stop it and revert it. So there are community tools that help with this, like PT Online Schema Change, Ghost, Spirit. The way how these tools work is they don't touch the original table, they create a shadow table on the side and start copying rows to the shadow table. And with this, there is control with throttling. So you don't take all the resources on the server, but you slowly copy all the data from the source to the destination. And at the same time, if there is a modification on the existing rows that are copied, it will apply the changes to the target table. When it's done, then it will just block the operations briefly, start, rename the original table to something else, and the destination table to the original table, and that's basically swapping the tables. These tools are also evolving, so resuming on failures is something that is in progress, but also there is important aspect for this change to be able to revert the DDL. So if you don't like the change after you did this, this community tools doesn't really allow you to swap back. High availability in MySQL, we can run on a single server, but that's not always ideal. Single servers crash, and we need to be highly available for production systems. Most production systems take high availability seriously. The way how this is done is that we need to have a copy of our existing database somewhere else. That can be active region, or it can be passive. So if region A dies, then the application will switch and start using region B. Currently, in MySQL, we can do this by cloning region A into region B and making region B to be a replica of region A. If we want to switch from region A to region B, the application needs to change the endpoint from region A to region B. And at changing that endpoint, you're switching all your read and write operations. Or if you're using some proxy, then you should be able to switch just the reads, start reading from region B, or just switch portion of your reads so that you warm up region B, and then you switch also your writes from A to B. So MySQL doesn't do that for you. This is something that you need to plan and make your application with all these changes. Handling node failures. Again, for high availability, it's important that the application has the information what is on the backend side. So what is the primary node? What are the replicas for this primary node? What would be the logic that the application will use? When my primary dies, then I need to promote one of the replicas to become the primary. That promotion is not something that the application can do, so you will have to do third-party. The community tools that exist today is something like Orchestrator, or this even might be MySQL InnoDB cluster, so the InnoDB cluster itself can promote a new primary. But it's important to mention that with losing the primary, the application may lose transactions. So the in-flight transactions, when the primary dies, the application should have that logic, hey, I didn't get a response, I need to retry this transaction. As well as if a replica dies, then the read operations that were sent to that replica will also return error. To resolve this, the application cannot speak directly to the replica set. We need a router. So the router has all the information for the backend. The logic, if there is a third-party application like Orchestrator, will take care of what is the primary, what are the replicas in case the primary dies, then a new replica will be promoted, and it will update the router at the same time. So your application doesn't need to know what's happening on the backend. It talks to the router, and the router gets the information from the backend. And this can be asynchronous application. It can also be semi-synchronous application, or it can be InnoDB cluster with group replication. And also, a small touch here is that a single router is also a single point of failure. So you will probably need to deploy your router to be highly available. And this is the solution from MySQL that works relatively well for high availability and disaster recovery. So here we have all of the single regions in a highly available setup where we have at least 3 nodes per region. We have 3 different regions for disaster recovery. So if any of these regions goes down, then the application can speak to the primary promoted in the other region. But the issue here is that we mentioned at the beginning, this single server is a MySQL server with limits. So you scale this server up to a certain limit, and then that's all. You cannot scale more than that. In some cases, the applications need read scaling, and for read scalability, we can add multiple replicas. So adding multiple replicas allows us to kind of horizontally scale our reads, but the writes are also something that needs to scale eventually, and scaling the writes can only be done on a single server by vertically scaling the instance and growing the hardware, so throwing hardware until we eventually hit the hardware limits. For doing read operations, there are different replica types that you can use. For example, for OLTP workloads, you can have replicas that just serve OLTP. You can have analytics replicas that your application sends analytical queries just to those replicas. There is option to also use delayed replica in MySQL, which can be useful also for disaster recovery. We can even go further. That one of the replicas can be intermediary master, intermediary primary, and we can add additional replicas behind. So scaling reads is somewhat easier. But let's take one actual example by a simple application that is a gym tracker. So something like these devices that we use and wear daily. We have users table, we have exercises. And the exercises table is something that has relatively small number of rows. So there can be 100-200 different exercises. And as we have users in this database, the users table grows, but what actually grows here is the exercise logs. Every user is generating tens, if not hundreds of exercises daily, and the exercises logs is what we have here as maybe 90% of the entire data set. Now, if we have this on a single MySQL server and the application talks to this single server, we know that after some time, the exercises logs will just be so big that this single server can no longer fit. So we can grow this single server, but that is not the actual solution for scaling MySQL. One thing that might work, and we have seen this, there is a functional sharding called splitting the databases into their own shards by torturing the application and having a router to go and query the users into its own users database, and the exercises logs will be on a separate database so that we can scale both independently. Maybe the users table doesn't grow that fast, but the exercises logs will be. And now, if we look at this, we have to query the user's database once, and if the user is requesting their exercise logs, then we have to go and jump on the other side and query the exercise logs for that user. So we may have to go back and forth depending how we design this application and what information we want to bring to the users. The next thing that we can do scaling this is splitting the exercise logs into their own shards. So we have the user's shard that is somewhat stable, but these exercises logs start growing, and this is where we actually need to have our application know where is the exercises logs from users 1 to 100,000, where are the exercise logs for users 100,000 to 200,000, and so on and so. So for this, the application will have to use some metadata that the metadata will be up-to-date information. Where are the exercise logs for these users? If something changes, it needs to update the metadata, so the application doesn't need to have all this complexity, but the router will pull the metadata and it will keep up to date. So this is not just about where are the records, on what shard we need to query. We also need to know and update the metadata whether the primary in shard 1 died or there was a replica that took over the primary. So all these changes inside the cluster, we need to update the metadata, and the application when sending the queries will need to know, actually the router that the application connects to will need to know what is the primary node and where the data lives. And going a bit deeper, we have the option to collocate the users and the exercise logs into the same shard if we split these tables and partition by, in this case, let's say, the user ID. So the user ID is something that exists in the exercises logs. So if a user with ID 10 is trying to query their data, the exercises logs for the same user ID will be on the same shard. So we don't need to go and jump in between shards, but the actual user data will always be on the same shard because we are partitioning and sharding this data based on the user ID. Now, if you notice, in this case, the exercises table doesn't have user ID, and while it's relatively small, we can afford to copy the exercises table on every single shard. So when we query shard 1, we have the user ID 10, we have the exercises logs for user ID 10, and we have all the exercises. So when that user wants to query their data, everything is on the same shard, and we don't need to scatter across all the shards. So this will be efficient query. Now the metadata needs to have all this information, and we need to update the metadata so the router gets all the details. And how do we do that? Well, all of these boxes that are MySQL, they are being controlled by additional process that knows what is the MySQL role in this cluster, whether it's primary, whether it's replica, how that, what is the user hash, what are the user IDs, and what is the exercise logs IDs that live there, and every single change that happens, that single process is updating the topology server, the metadata. So how that looks like, this is actually what a Vitess cluster looks like. So we have routers in the middle that are stateless. The routers get the metadata from a topology server. Usually there is a network load balancer in front of the routers, and the application connects to a network load balancer. Then the routers, the VT gates, talk to every shard, and when a query comes based on the shard ID, it will go to the designated shard, so that can be any shard, but it's only one. That's important if we have a properly configured sharding. So in this case, if it's user ID 10, and we are sharding on the user ID column, when the query comes, it will always go to a single shard, and we don't need to scatter the queries across all shards. So what are the concepts in Vitess architecture? We have a concept of a key space, and this is logical database. If we look at MySQL concept, this is like a regular database. Each key space consists of multiple shards, and every shard is a it can be a 3-node replica set, it can be more replicas with a single primary, but it usually is one primary and 2 replicas. Each of the MySQL instances is being controlled by a process called VT tablet. So VT tablet is the process that is controlling the MySQL D underneath. When MySQL D is starting, if there is a failure, bringing up MySQL. If the process dies and it needs to restore from backup, VT tablet is the process that's responsible to do all that. And VT gate is what is talking to VT tablet. VT gate is pulling the data from a topology server that usually is etcd. It can be Zookeeper. I think Consul was option in the past, but it's deprecated. The VTCTLD command is used to update the topology server and do changes on the Vitess cluster. VTORC is the process that takes care of every single shard topology. If a primary goes down, then VTORC will be the process that takes care of promoting a replica to become a new primary. And VTadmin is just a web user interface so that you can see the entire Vitess architecture in a nice web interface. And Vitigate also speaks the MySQL protocol, but it talks gRPC, so your application can also talk gRPC to Vitigate. When Vitigate gets the MySQL connection, that's where it's terminated, and Vitigate to VitiTablet speaks just gRPC protocol. And inside the entire Vitess cluster, it's gRPC. This is one slide showing some of the logos that are using Vitess today and scaling MySQL with Vitess. I briefly touched on the Vitess concept. So the key space, the logical database, consists of multiple shards. There is also Vitess schema. So this is the schema that Vitess is using to know what are the key spaces inside the Vitess cluster, how do we shard our tables. The V-index is the index that is showing what is the key space ID that belongs to a particular column that we shard on. And while Vitess is complex on the backend and it consists of multiple shards, and there are a lot of databases on the backend, it provides an illusion to the application. So the application is like connecting to a single MySQL backend. The application doesn't need to worry what's on the backend, where is the primary, where is the replica, and it does that by the power of vReplication. So vReplication is something in Vitess that is used for importing data into Vitess. So you can copy data from external MySQL into Vitess. You can use vReplication to move data inside Vitess. So you can copy, for example, your users from one key space to another key space, or reshard. And you can materialize. So the example that we were using for exercises, we can materialize the exercises table across all Vitess shards. And how the vReplication works, it just selects star from the table, and it starts streaming the rows to with a vStreamer, and it applies the rows on the target with a vCopier. It does that for a default of 1 hour, and after that 1 hour, it goes and scans the binary log on the source, and for the already copied rows, if there is any change, then it will apply on the target. With this, we can import data from external key spaces to Vitess, and the way how this works is Vitess has a move tables command. It creates a vReplication workflow. Then once we copy with vReplication, we can run vdiff. So Vitess also has this vdiff operation that it checksums the source and the target, and then it makes sure that both source and target are the same rows. And once you are comfortable that there is no data drift between the source and target, you can switch your application from the source to the target by doing first switching read operations and then switching write operations. And you also can roll back, because when Vitess switches the write operations, it will do a reverse workflow. So eventually your target becomes a source and your original source becomes a target. I have a vReplication demo, but I don't think we will have time. So we have a boot to 15, so you can come and check this vReplication demo in action. The vReplication also allows you to do online schema changes. What I want to mention here is that there is a online schema change that is online, and even if you have hundreds of shards on the backend and your application is connecting to a single MySQL endpoint, when you do a change, the vReplication takes care of everything, and Vitess will run the change on every single shard. Now, this may look simple, but it has to coordinate every shard. It has to go, and all of these shards might take different time, so it has to wait that all shards are at the exact time before it actually does the DDL operation. So Vitess has this native, and it also has an option to revert. This is based on the vReplication. You can watch the migration live, so when the migration is started, it has a record in Vitess migrations table, and it's reversible. So once Vitess is finished with this change, you don't like it, the application is having impact, you didn't think that this change may cause negative impact, but at the end it did. So you can just do revert Vitess migration, and you will be back to where you were. So with hundreds of shards, you have the ability to just say, go back. And Vitess also supports this declarative migration, so you don't need to run alter table, but you just say create table, and it will figure out what is the difference between the source and target, and it will apply the change. So the schema changes are easy. Maybe by some, it's much easier compared to you doing this with some other community tools. It's easy to reverse, and it's all powered by the vReplication. So summary, MySQL has limits. Vertical scaling is definitely not an option. You will hit the wall after some time. Horizontal scaling is what Vitess supports, and it's a sharding framework that pretends to the application that this is a single MySQL server. It's all powered by the vReplication. Online schema changes are made easy by the power of vReplication. It has built-in high availability and disaster recovery, so you also don't need to worry about whether any of your shards has high availability, and you don't need to do any application changes. Your application can talk to a Vitess cluster with any legacy code, with any ORMs or frameworks that you have. With that, thank you, and open for any questions. Yes. So the minimal infrastructure is that you will have at least one shard, so that's one primary and two replicas. You will need to have etcd for topology server. That's also 3 etcds, but that is not like a huge hardware requirement like you would do for MySQL. You will need VT gates. So that's also something that can live maybe in Kubernetes. You can have this in auto-scaling. And also Vitess has a Kubernetes operator that's open source. Mostly, yes. But you can also deploy it on virtual machines, like on EC2. It's just all of these components, they will have to be highly available. You will need to have you can run multiple instances on the same machine, but you will just need to take care that these machines need that many resources like CPU, memory, disk, but that's like, you will need VT gates, at least 2 for high availability. You will need topology server. MySQL, at least 1 shard will be primary and 2 replicas. And if you are in the cloud, you may be putting that behind load balancer. So these are the hardware infrastructure requirements. That's all? Okay, thank you.
Okay, hello. Oh, there's still more people. Hi. Okay, how are you guys? That's great to hear. Okay, so today we're going to have Gabriel Siciliani from Relum talk to us about the hidden life of internal temporary templates. So let's give a round of applause to Gabriel.
All right, cool. Much better. All right. Hello, everyone. Excited about spending the next hour talking about MySQL internals? Yay, right? Who wouldn't be? So let me see some hands. Who's running MySQL in prod here? All right, 1, 2, 3, okay. Any mission critical applications? Or just prod, but not so much? All right, cool. Anyone thinks that Postgres is better than MySQL? Okay, cool. Yeah, you're in the right session then. And if you do, I want to know you have some facts to support that. But yeah, we can talk about that later. All right, let's see what this is about. So I'm going to start with doing some introduction about temporary tables in general on MariaDB and MySQL. We're going to see how those temporary tables works, how the mechanics, right? And we're going to see like what telemetry we have available to see to measure those temporary tables. We're going to see why that is important. So I'm going to show you some commands and some strategies to deal with them, and and finally we're going to do some lessons and takeaways. Feel free to ask any questions. Let's keep it keep the questions coming. If you have any questions, just interrupt me. Go ahead and ask for a microphone. I'm good. We don't need to wait until the end of the session. So with that being said, let me a brief introduction. I started as a junior Oracle DBA back in 2006, as many other DBAs. Then the company I was working for, they found out they were spending a lot of money on Oracle, and they said, okay, we're gonna start using MySQL, and that's when I moved into that world. Since then, around 2014, I did a lot of work around MySQL as a DBRE consultant, and even some development as well for one of the big cloud providers. I started building Tuning Wizard October 2022. That's automatic query optimization API that was then acquired by Relum last year, and since then I'm helping them to take automatic server performance optimization to the next level. And I'm from Buenos Aires, Argentina, by the way. So yeah, the land of Messi, tango, inflation, right? So yeah, that's where I'm from. So if you're thinking Argentina is the right country, you're wrong. That's actually Brazil. We are down there, right? That's a lot of confusion. There's a lot of people think Argentina is part of, Buenos Aires is part of Brazil. We're down there. So in case you were wondering. All right, so kinds of temporary tables, right? There's a lot of, you use the term temporary tables a lot with MySQL, MariaDB. So we have user-defined temporary tables, the ones that you would create with a create temporary table statement. Not the ones we're interested in today. You also have temporary shadow tables when you're doing some schema change, right? And that schema change cannot happen in place, so you need to create a copy of that table. Those are called shadow, right? Also, temporary table, not the goal of this session. So we are not going to be talking about those. We're going to be talking about that third item there, internal temporary tables, right? So those are temporary tables are created automatically by the server during query execution, right? So why are they created, right? Usually because you need some additional, so the server needs some additional space to compute that result, right? So it allocates some more space somewhere, and we're going to see where, of course, probably memory disk, to perform that query analysis and to compute that final result, right? And, the question is, why should we care about this? Like, it's okay, so cool, temporary tables and stuff, but why should we care about this, right? And of course, these temporary tables are created during query execution, and anything that's created like during the execution, of course, is on the critical path, and it will burn execution time, right? It will make your query to run slower, so you should be caring about that. You should be asking yourself, okay, what the query is doing, and if it's burning time on temporary tables, then why? Is there anything we can do, right? So performance, right? That's usually the answer. That's why it's interesting to see how this works and understand a little bit more about them. So if you check the documentation, there's a lot of situations or scenarios where temporary tables are created. MySQL has a good list. MariaDB not so much. You're going to see, you're probably familiarized with MariaDB documentation. Sometimes it's not so good. But yeah, I wanted to focus on these 4 cases, which are kind of the most common ones. So group bys and order bys, around those operations, there's a lot of good chances of having to create temporary tables, especially if you're doing like group by and then order by, and those 2 clauses are different. Well, it's probably the server is going to be generating a temporary table for that. Usually group bys are not using any indexes are going to resort to a temporary table. So those are like, again, around group bys, order bys, there's probably a lot of chances you're getting a temporary table if you are not using an index, right? So subqueries, right? That's another scenario. When you run a query, you use subquery as a table. Sometimes that needs to be materialized, right? That subquery needs to be converted into some temporary table so the query can continue executing. That's another scenario where you will get a temporary table. Multi-table updates, you're doing updates, you're doing a join. That's another scenario where the server will build an internal temporary table first to then proceed with execution. Another scenario, perhaps not that common, when you do an insert select and the same table, you're reading and writing on the same table, then also temporary tables are created. And there's a lot of other scenarios, but I think these are the most common ones. You're probably familiarized with this. And yeah, we're going to see later how we can actually spot this, right? It's not that we need to rely on some list. We can actually ask the optimizer if a table is being used, right? So, at a very, very high level, right? Very simply. So the optimizer knows that it's going to need a temporary table, right? So the query execution starts, that temporary table is created in memory, and the query starts adding rows there, right, on that portion of memory. Of course, there's a threshold, right, because you're using memory, and these tables are allocated per thread, so you can just let threads go wild and allocate all the memory they need, so you need to set some sort of threshold there. Probably familiar with that parameter, TMP table size. That's going to be your main threshold. If the memory usage is below that, then the query is just going to create a table of memory, it's going to use it, it's going to drop it, and you're done. The problem starts when you hit that threshold, right? So no more memory can be used. Then the server spills that table in memory, on disk, creates a copy of all the rows on disk, and then continues to work on the disk copy. So that operation of moving rows from memory to disk is usually expensive in terms of total execution time, right? You can argue that, okay, how expensive it is. It's, I don't know, another 10 milliseconds, 20 milliseconds. It could be considerable, right? Especially if your result set has 100,000 rows or a lot of rows. That copy operation is expensive, right? And that's definitely something you want to avoid because it's adding execution time to your query. So this is how it works at a high level, right? So historically, for the memory phase, the memory engine was used, right? MySQL, MariaDB, multi-engine server. So you had a special type of tables that are created in memory. And developers said, okay, we need to put rows in memory. We have already this engine already created, so let's reuse that, and let's use memory internally, this memory engine internally to store our rows in memory. And then for the disk part, right, when you had to move to disk, MyISAM was used back then. Starting with MySQL 5.7, InnoDB was introduced for temporary tables. That's because MyISAM has some limitations when it comes to the additional files that are generated every time you create a MyISAM table. MyISAM uses this key cache, right, that has a mutex that acts kind of as a bottleneck, right, when you have multiple sessions trying to use temporary tables. So that was not scaling pretty well. Of course, MyISAM is not crash safe either, so sometimes the cleanup, if the server crashes, could be complicated, right? You could not just, you lost the track of that file. So they said, okay, let's use InnoDB for that. Let's create this temporary table space that was also introduced in InnoDB 5.7, and let's store our temporary tables there, right? And it's cool. We know that everything's on that temporary table space can be wiped out when the server shuts down, or can be wiped out when the crash recovery happens. So it's completely safe. My InnoDB is a memory-first engine, right? So everything will go to memory, both data pages and index pages, as opposed to MyISAM that only caches index pages. So it was, performance was better with InnoDB. And with MySQL 8.0, the Temp table storage engine was introduced that will handle both the, for the memory part, right? So the memory engine was kind of deprecated or left aside, and the Temp table was introduced. I'm going to show you a little bit more about this Temp table engine because it's kind of interesting, and it works. It's a little bit more complex compared to the memory engine. MariaDB, on the other side, it's still using memory, right? The approach is still the same. I guess the only difference is that they started using this area engine, right? It's this evolution of MyISAM, like crash-safe version of MyISAM for the on-disk part. But the memory portion is still using the memory engine. So as I said before, Temp table it's a little bit more complex, right? It has this additional overflow layer, right? Where once you're done with your memory space, it will go to these mmap files, right? So another limit was introduced into the server, another parameter, which is called a temp table max mem, I think, or mem max, max RAM, sorry. So when that limit is hit, that's a global limit, right? It's not the same as TMP table size, which is only for the thread. So when that limit is hit, this mmap mechanism kicks in, and the server will continue to write a memory, thinking it's memory, it's just memory, but behind the scenes, the kernel is actually swapping those pages to disk as needed. So it's kind of it's better than having to stop and create a table on disk and copy all the rows. But of course, it's a little bit less performant than working with memory directly. And of course, you have this second threshold, which is the temp table max mmap. When that one is hit, then you end up on InnoDB tables. So it's interesting. Again, with temp table, these other two thresholds were added, and those are global, right? Those work at the server level. So with 5.7, again, I wanted to cover 5.7. I know there's still people using it. So the internal TMP, so this internal TMP disk storage engine variable was introduced. So you can switch to InnoDB. You can go back to MyISAM if you are nostalgic or something, or you want to still use it. But yeah, InnoDB was made the default. Works well. And of course, because we were still using the engine, memory engine, you still need to deal with TMP table size and max heap table size. You probably, if you did some MySQL tuning or you read some courses, some books, you know that those two variables need to go together, right? Max heap table size is actually a parameter that's related to the memory engine, right? But because you are using the memory engine for temporary tables, it also limits the size of your temporary tables. So the code everywhere has this like min between choose the minimum between those two, right? So you usually want to move those together, right, when you're using memory engine, just to prevent one from limiting the other one. So because the server will use whichever is smaller from those two. And again, historically, that's because the max heap table size it's a limit for the memory engine itself. So that's why you need to keep both into consideration. With 8.0, again, you don't need to, if you're using temp table, you don't need to worry about max heap table size anymore because you're not using memory anymore. But you have these two other thresholds that are at the server level that I mentioned before, the max RAM and max mmap, right? So how does it work, right? When you have temp table size and max RAM and max mmap. So you can think of max RAM and max mmap as a total memory space that you can, but all the other restrictions won't apply. So in case you were wondering, okay, so is it temp table better than memory? Kind of it is. Again, it was created just to replace it. And I guess a good thing about temp table is that it's more efficient when it comes to memory. It will not. So memory is kind of is fixed. You know, the space allocated is fixed length based on the data types. When it comes to temp table, it will actually allocate the memory it needs. So let's say you have a table that has big int defined as a data type, but you have all your values are just 4 digits. Then temp table is just going to allocate that space for those 4 digits, right? It's not going to allocate entire 8 bytes just in case you have large values. Memory will do that. Temp table will be more efficient and will just allocate what it needs. As I said, the overflow behavior, right? A memory doesn't have that. Temp table does have this mmap-based overflow. And yeah, of course, it supports blob and text, which memory doesn't. So it's kind of better. I guess it's a better option. It's more efficient, supports more data types, and it has this intermediate overflow layer with mmap. Telemetry. So again, if you did any query tuning or any server tuning before, you're probably familiar with those two counters. The second one, created TMP tables, is a counter that will increment every time a temporary table is used, and created TMP disk tables is incremented every time that table is spilled to disk. So with those two counters, you can compute you can say what percentage of my temporary tables are going to disk. So if you get that number is 80%, 90%, then of course it's a pretty basic indicator that you might need a larger TMP table size or max heap table size if you're using memory. So that's kind of the key ratio that you will calculate when you're dealing with temporary tables. Then, well, with MySQL 9, this other counter was introduced just to keep track of every time you hit that global server level. Remember this temp table max RAM parameter. So it will increment every time you hit that. And of course, it's telling you if that counter is moving, it was going to tell you like you need to bump that up. Some more telemetry, MySQL. You have some stats on the performance schema. You have a couple of instruments there, physical RAM, physical disk. Physical disk is kind of confusing. Initially, I thought it was tracking the on-disk activity. It's just those stats are tracking the mmap activity, actually. So every time you spill, that second overflow layer kicks in, you're going to see some stats there about the memory being allocated. So, but yeah, it's for mmap. It's not giving you any details about like the on-disk tables, like the InnoDB tables. Yes, there's a bug this bug was raised. Also, it can be a little bit confusing, right? When this mmap layer kicks in, this overflow mechanism kicks in, you're writing memory, but that memory is being swapped to disk. So there's some disk activity. It's not pure memory activity, but the created TMP disk tables will not increment with that. It will only increment if the tables move into disk. But yeah, someone thought that was kind of confusing and raised a bug about like, hey, why do we make this counter to move when it's using mmap? But I think I'm not sure. It's not closed yet. And yeah, again, is debatable, I guess. But yeah, keep that in mind. Like if the mmap thing is kicking in, you're not going to see that counter moving. All right, so how do we know if my query is using a temporary table? That's a fair question, right? As I said before, the optimizer determines that. So you can just run explain. I love the JSON format. I'm a JSON format fan because it's much more comprehensive and detailed. And in particular, I'm a fan of the MySQL output because it's much better than MariaDB, unfortunately. It's better, much more consistent and detailed. So you can see for different scenarios, when you run explain, you're going to see like, okay, duplicate removal, like distinct or group by, is going to say using temporary table true, so very, very, very verbose, very, very clear. When materializing a subquery, you also have the same key, same with sorts, same with grouping operations. So it's pretty easy. You just get the explain, and you will see if a temporary table is in the optimizer plan or not. Of course, that's going to tell you if a temporary table is being used. It's not going to tell you if it's going to go to disk or not, right? Because that depends on how big that is and what your settings are. So it's just going to say, okay, a temporary table will be created in memory at first. Also, it's not taking any limitations into consideration, like blobs or anything. This is the MariaDB counterpart. As you can see, it's not super verbose. You have this file sort section, and if a temporary table is used, you're going to find this temporary table section there. Kind of confusing. You don't know if you have multiple operations, like group bys, order bys, distinct on the same query. You don't know exactly which one is triggering this temporary table. So it's not cool, but at least you know, okay, temporary table is being used. So another cool thing that you can do with MySQL and is to actually determine if the table was moved into disk, right? MySQL has this cool optimizer trace feature that's like an explain on steroids that will give you, it will not only show you the execution plan, but it will show you all the steps that were done to process that query, to optimize it, to simplify it, what decisions were made by the optimizer, discarded plans. So it will show you a lot of interesting stuff if you're like really, really deep diving into some query, trying to understand what's going on. And included, it's going to show you, hey, the temporary table was moved to disk. So you would set the optimizer to enable, you set the max mem, you run the query, and then you check the information schema optimizer trace, and on the entire output, you're going to see something like this. Of course, it, again, is you need to actually run the query, right? Because otherwise, the temporary table will not be created. But I know it's kind of small, but it's going to say something like converting TMP table on disk. It's going to say the cost, memory table size exceeded. It's going to show you the location, disk, InnoDB in this case. So it's, again, if you are really, really trying to understand what's going on, or if with your current configuration, the table is going to disk or not, then optimizer trace is a good tool to confirm that. Only available in MySQL, unfortunately. And another fair question is, can we, so this is cool, right? So of course, memory is faster than disks. Is there a way for me to estimate this, right? And actually, this question was the one that triggered a little bit of investigation on my side and ended up becoming this session, right? Like, I was trying to provide our customers like some minimum TMP table size they need to set for their query to go to disk. Sorry, to stay in memory. Again, for some specific queries, it's good to know. And so my idea was, okay, for a given query, can I tell you what minimum TMP table size you need to set? So for memory, it was straightforward, right? As I said, fixed length storage, so you know what the columns are part of your projection of your query. You know the data types. You roughly know the amount of rows. So you can get a pretty good estimation of how much memory will be used. You can set that on TMP table size, and your table is going to stay in memory, right? So it's kind of straightforward. With temp table, I had a lot of back and forth. Was trying to understand why numbers were being different. So first thing I found out is that if you go to, I was experimenting with very low TMP table sizes, right? Like kind of 16K. I was trying to force that table to go to disk, right? I wanted to see how it behaved. You know, I was putting like very small values, and I was not seeing any temp table activity, right? It was like, what's going on, right? I ended up finding out that there's a minimum allocation size for a temp table engine, right? And when you go below that, the server says, I'm not gonna allocate any temporary table on temp table engine. I'm just gonna use the store buffer. It's like, okay, so it will just go with the store buffer. It will use something more similar to what is done for sorting, and none of the stats are gonna apply. None of the mechanisms are gonna kick in. It's just gonna use the store buffer. So that was confusing. And of course, then the temp table engine has these 3 layers, so you need to keep that into consideration. What's the TMP table size, but also what's the temp table max RAM, if mmap is going to kick in or not. So it's harder to track where the table actually is, right? And the other thing is like the actual estimation is not that easy because it's allocating the memory it needs, right? Temp table is allocating the memory it needs and it's not using the data types as it's not allocating the full space. So it depends on, it ultimately depends on your data size. So, but yeah. How are we doing? Okay, cool. So lesson number 1, right? Like, if you can avoid temporary tables, of course, we should do that. Again, these are adding additional computing, additional work that your server needs to do in order to get your query. So union versus union all, that's an easy one. You probably heard this one a lot of times. The union all is preventing that deduplication phase that usually requires temporary tables. So again, if you don't need that, if you know both queries are unique, they are returning unique values, then you can get rid of that. Of course, every time an index is used for a group by, order by, it's very likely that the temporary tables will not be created. So that's not like a way to avoid them. I created this. Sometimes people they don't know that the index can be used for group bys and order bys as well, and they can be used for both, right? Like for the actual filtering, like the actual to process the actual where clause, and the group by or the order by. So I put a few examples there, right? For an index that's ABC, if you have a where A value and group by B, the index will be used. You have where A equals value group by B and C, the index will be used. Of course, the order of that group by BC, it's important in that case. If you do group by CB, then that index won't be used for the group by. Another example, value A equal value, B equal value, and group by C. Again, the full index will be used. And another example where you have a range condition where it's C greater than value, group by C, it would still use the full index both for the where clause and for the group by. So you get the idea, right? So you need to keep the order. You need to make sure that any range condition is using the last column of your index, and the group by is done by that range condition. But if you stick to these rules, you can avoid temporary tables for most group by and order bys. Of course, if you can avoid the temporary tables, let's try to keep them in memory. That's kind of obvious. How we can do that? Of course, TMP table size, which we can try to estimate it. We can experiment with some values. I show you a couple of tools, at least from the MySQL side, where you can estimate, or you can actually check if a temporary table is being spilled to disk or not. Keep in mind that TMP table size is a session level variable. So if you have a large query that's using that is going to use a lot of memory, you can bump up that level, that parameter just for that query. That's completely fine. And of course, max keep table size if you're using the memory engine or you're using MariaDB. temp table max RAM. Of course, keep in mind that's the overall memory limit that all sessions that like the full space that all threads are using is going to be limited by that max RAM value. Well, of course, if you're using MariaDB, try to avoid block and text, right? Sometimes you do select star, or sometimes you include some columns, or you kept them and you don't really need them, just get rid of them, right? And same with large columns. Another good reason to be conservative with the data, with the column sizes. Try to keep things below 512 if you know you can. And again, that will prevent things going to disk directly. And that's all I have for today. So it's now time. If you have any questions for me, I can answer. Of course, I'll happily do it.
Does anyone have any questions? You can raise your hand, and we'll come to you.
There's a microphone there if you want.
Yeah. So it looks like you focus mostly on MySQL tables. We use MariaDB, and so we have an issue here where things are being slowed down because we're creating a lot of temporary tables. So I want to so would you suggest migrating from MariaDB to MySQL, or do you think MariaDB, because it looks like kind of you focus more on MySQL, so is it something where like ARIA can work, MariaDB doesn't have the temporary table storage engine, for example? Is it worth it for something like we have, or is it more something more where you think we should kind of analyze the queries to see what's creating the temporary tables and adjust those, the max and things like that?
Yeah, it's a good question. Definitely, the work. MySQL put a lot more of developer work into the temporary tables management. MariaDB is still handling things as like 20, 30 years ago. And yeah, I have to say it is more efficient, right? If you have a severe situation where you're dealing with huge queries, huge group bys or huge subqueries, and you really need to keep that memory usage under control, you have a lot of concurrency, that might be a good strategy. I know moving from one to the other is not easy. They're not fully compatible anymore. But yes, temporary table is better handled by MySQL, right? And you have more telemetry, and you have more tools to troubleshoot that and to see what's going on, right? The optimizer trace, the explains are more clear. Temp table is more efficient. You have additional layers. Yeah, it's definitely better. Management is definitely better. I think you had a question.
Sorry, who has a question?
So a lot of this talk was about performance and about storage limits. Do you have any notes about retention and about, let's say, running multiple similar queries, slight differences between them consecutively, and how that might change some of the considerations between memory mapped and disk storage?
So the question is, how would this how the mechanics would work with different type of queries?
Yeah.
Kind of.
Yeah.
Feel free to if you want to. That's what I got from the question. But if it's not what you said, just feel free to re-ask. So what you're interested in to know, how is handled? How are different type of queries handled, or?
Not so much the different types of queries, but possible disadvantages to relying more heavily on the MySQL strategy versus the MariaDB strategy, where there's more disk usage with Maria, and I was wondering if there's any other cons with the strategy where we use a memory map phase instead of going directly to disk. Okay.
Yeah, I kind of, it's kind of related to the previous question. So MySQL has a better management of that temporary space, right? Because the temp table is more efficient, and even adding that intermediate layer where it's using mmap, that's usually up to some point is better than going to disk directly. So it was a kind of a smart move. They said, okay, if let's say you just need a couple more megs, right? Let's just use this memory, this mmap, memory map files, right? This additional memory that's actually mapped to files on disk. Instead of, so for the server, it will continue writing on memory as if it was memory, but it's actually under the hood, the kernel is doing this swapping, right? So there's going to be more disk activity, but it's definitely cheaper than stopping things, creating a table on disk, moving all the rows there, and then continue working on InnoDB. So again, like it's as usual, it depends, right? Like usually it's better if you can stick to memory and mmap and without going to disk, of course. But I guess it depends a little bit on your workload. For me, it's like that mmap approach is like a last resort, like a last attempt to try to keep things in memory before it goes to disk. So it's a good idea, but again, if your parameters are too small, then yeah, the server is just going to go over them. It's going to use the RAM, it's going to use the mmap, and it's going to go to disk directly. So it ultimately depends on your configuration and the query. So it's a work you need to do with your workload, right? But again, you have definitely more options with MySQL than with MariaDB, right? MariaDB is still kind of legacy the way it's working with, it's dealing with this memory, and temporary tables.
Does anyone else have a question?
Is there a way to optimize like PHP when you're actually writing the code to avoid this entirely, so you don't have an issue with the temporary tables?
So for PHP language specifically, last time I touched PHP was a long time ago. I guess, a lot of ORMs, like if you're using some sort of ORM, they don't build the best queries. I don't think there's anything specific to PHP. What you can try, like if you have some hot queries that are taking long, or they are doing some group bys, order bys, or they are using distincts or subqueries, you could try to override what the ORM is doing and try to write your own query. And of course, you can try to create an index using this approach I show you. Like try to use an index where you can map not only the columns on the word clause, but also the ones on the group by and order by. But again, that would apply to, I guess, any language. It's not as specific to PHP, to be honest. But yeah, it's very common that the ORM sometimes is not giving you enough flexibility. So it's better just to override that query the ORM is building and put your own query, right? Most frameworks allow that.
Okay, yeah. Is there any way we can get a copy of this?
Yeah, I think they're going to be available, I think. So I'm happy to send you a copy. Sure.
Anyone else? Okay.
All right. Thank you, guys.
Let's
Have
give
a
him
good
a
one.
round of applause. Thank you.
Oh, yeah, thanks. Yeah, I think they're going to be available. So, but yeah, I can send you a copy directly.
1, 2, 3. Should I get started? Yeah, we can get started. The most popular spots right after lunch? Yeah, yeah. Yeah, that's fine. I say Matthias, but yeah. Growls. Yeah, sure. Okay, it's fine. Yeah, sure. Yes.
Hello, how are you guys? So today we have Matthias Crowell. He's coming from Planet SCaLE to talk to us about Are You Ready to Leave MySQL 8.0 Behind? And let's give a round of applause to Matthias.
Thank you. The spot right after lunch, the most popular one. Everybody's still digesting. So this morning there was a question, is MySQL dead? And that's not really what I meant with this title. It is a talk about upgrading from the current 8.0 version that is going end of life in April this year to the next long-term releases that they are announcing. So who am I? My name is Matthias Krauwels. I live in Belgium, in Ghent, and I've been a Linux user and administrator for over 30 years. Started in my teens running Linux on all kinds of machines. Then I was professionally a PHP developer in the typical LAMP stack that most people know about the early 2000s. And no one in our team had any clue how the M in the LAMP stack worked. So I started learning about MySQL, and I became a MySQL DBA. Previously, I was a consultant for a Canadian company, and currently it's my 4th year at Planet SCaLE. I'm in the enterprise customer engineering team, where we support our enterprise-type customers in their road into Planet SCaLE and in their success with Vitess. This talk, however, is not a Planet SCaLE or a Vitess talk. It's a regular MySQL talk. So let's get started. MySQL has been the most popular open source database, still is. If you look at DB Engine's ranking, it's still the most popular open source one. It's been declining, however. It became 30 years last year, and it was the default database of choice for a long time for many developers. And in the last decade, that has shifted to more towards Postgres. I can't really explain why. I don't have anything against Postgres, but I still like MySQL a lot. So we can see what the future will bring. And MySQL releases before, they were always like every 2-3 years there was a new major release, going from 5.1 to 5.5, 5.6, 5.7. And then in 2018 they decided to start releasing a new version, MySQL 8.0. It was originally planned to be 5.8, and then they decided to renumber to 8.0. They didn't go to 6 because MySQL 6 was a version that they worked on for a long time when MySQL was part of Sun. That never really was released. MySQL 7 is what's it called again? The enterprise one with the NDB cluster. That's the one, it's MySQL 7. So then they decided, let's go to MySQL 8. And they would release a new point release every quarter until the database would hit end of life. So you can see there from 5.5 to 5.7, every 2-3 years there was one version going end of life. And so 3 years after the last end of life for 5.7, 8.0 is going end of life this year in April. And typically MySQL has always had 2 supported major versions. And so when 5.7 went end of life, there was only MySQL 8 left supported. So then the MySQL release team decided they needed a new release plan, and they came up with something called innovation releases and long-term support releases. And every time a new version goes end of life, they made a contribution to also create a new LTS release. So the current LTS releases are still 8.0, current version 8.0.44, which goes end of life now in April. And then the other long-term support release that's currently available is 8.4, which is current version 8.846. And the next long-term release that they're planning is 9.7 in April. So this is their release schedule. So you can see that 8.0 has been the legacy version that they still do bug fixes on until now. So the last version of that is going to be released now. And then they created all the innovation releases, 8.1, 8.2, 8.3. And those are meant to be like single releases. There's no follow-up releases for any of those. And then they make a new LTS version, which then has support releases for a longer time. As you can see in the numbering, like after 9.7, which is up here, there, you can see they're planning to go to version 10. And that's going to be a problem for some things, because there's a fork of MySQL ever since MySQL came to be in the possession of Oracle. There were many people that thought that Oracle would kill MySQL, and so the original author of MySQL created a fork called MariaDB, and they started renumbering their versions after 5.5, which is the version they forked off, to 10.0 and above. Their current LTS version is 11.8. And so a lot of the tools out there, if they do a version check and they see version 10, they will assume that it's going to be MariaDB, and they will behave different. So that's one thing to be careful of. So now there will be a MySQL version 10 as well, and that's not going to be MariaDB. The innovation releases, they're not meant for production workloads, and they're basically the way to introduce new features into the server. For a while in the 8.0 releases, every major version, every minor version that they release, so every point release, could contain backwards breaking changes, which was not very convenient. At some point, they released a version of 8.0 that changed the redo log format, and that broke everyone's backups, which was kind of dangerous. So that's what they wanted to fix with those innovation releases. So they are not meant for production workload, but they're a good way to test new features up front. And there's only going to be one release. So there was an 8.0, 8.0, 8.10, 8.20, but there's never going to be an 8.11 or an 8.21. They're just released every 3 months. And then the LTS series, they are scheduled to be approximately every 3 years to have a new LTS release. So the current legacy one is the 8.0, which will have its latest release in April. Then the current version for 8.4 is 8.4.6, which was released in January, and the expected release of 9.7.0 in April when 8.0 goes end of life. So MySQL 8.4 removed many of the old 5.7 syntax that was deprecated in 8.0 already. Like they made a point to get rid of the master-slave nomenclature, and they went to replica and replication source instead. And so while in many of the tools that you were using before, you would run something like show slave status, that would still work in 8.0, but it's now gone in 8.4. So if you haven't updated your tooling yet, it's the time now really to do so, to change that nomenclature. They changed the master designation to replication source. So if you want to set up a replica, you have to no longer change master to, but you have to change replication source to. And the command like show master status has been replaced by something called show binary log status, which more covers the load of what the command will do. MySQL 8.4 does in-place upgrades. So if you start a MySQL 8.4 binary on a data directory that was running on MySQL 8.0, it will automatically upgrade your data directory to 8.4. And there's no rollback from that. So it's a single way transaction. So if you want to try to upgrade, do not run this the first time in production. Like test it first before you do something like that, because you cannot just roll back. You would have to restore a backup, which might let you lose some data if you don't have regular backups. So the latest point in time might be a bit behind. They also removed the MySQL native password authentication plugin. So if you don't do anything and you just upgrade your MySQL 8.0 to 8.4, and you're still using MySQL native password for your users and your root user, you will not be able to log in anymore. Like the plugin has now been disabled. It's not fully removed yet, so you can still enable it in 8.4, but they will fully remove it in 9.7. So it's important that you know to first upgrade your passwords to the caching SHA-2 plugin, which is the new way of encrypting passwords, which is not reversible anymore. So that's very important to know. Also, in a previous life, I was running and building systems using Puppet. And the Puppet MySQL Labs, Puppet Labs MySQL module still doesn't have proper support for caching SHA-2 passwords. So if you're running, managing your MySQL servers using Puppet, you will run into issues there. Things that all the things that they removed in 8.4 is the auto increment. It does no longer work for float and double types. Which made sense, like auto increment has always been an integer So if you choose a float or a double type, it's not supported anymore to put an auto increment. You'll get a syntax error. They removed the expire logs days, which is the expiration for your bin logs, and they made it bin log expire log in seconds. So now you have much more granular control of how long you want to keep your binary logs, because before it was just in days, so you had to specify how many days you want to keep them. Now you can specify in seconds, so if you set it to 1 second, your binary logs will basically disappear immediately. So make it a sane value. We typically say like 3 days or 7 days is a good value for your binary log retention. So that's there. And also the old SSL parameters are removed. They're new SSL parameters. But this is also something I ran into using Puppet. If you don't do anything to your Puppet recipes, and you deploy it with MySQL, Puppet Labs MySQL module, it will add an SSL keyword in your config file, and then your server refuses to start up on the new version. So there's a setting skip SSL that you need to set in the Puppet, which is then counterintuitive because you actually are not skipping SSL because you're using the new version. Then the upcoming 9.7 release, which will be released in April. Oracle announced the new version on the Belgian MySQL days earlier this year in Brussels. And the things they said to be in the new release is they're going to decouple the foreign keys from the storage engine, which will make it which will make foreign keys supported throughout the server now, while before it was only supported in the specific storage engine. They added that in the innovation release 9.6, which was released in January, and it's gonna make it. It should make it into the upcoming LTS release in April. They added a new native vector data type in MySQL 9.0 earlier, and they're gonna also include that in the upcoming LTS release. They're adding support for JavaScript stored procedures. They're going to enable the new hypergraph optimizer by default, which they use for their heatwave deployments in OCI. And they said they're going to be performance improvement. So we'll see. But most important, there was a commitment from Oracle, from the MySQL team at Oracle, to work closer with the community again, because there was some dissatisfaction from the community about the fact that Oracle is not very open in what features they accept as contributions. It's not very clear how you have to contribute. Like if you open a pull request in GitHub, you basically do not get any answer for many months or even many years, which is not good for community engagement. And so they promised, they're making some changes inside of the Oracle corporation, where MySQL is going to be positioned in a different place, and they're going to have a new vice president leading that effort, and their commitment is to work much closer with the community. So we hope that that yields any improvement there. So how do you upgrade from a previous major version to a next one? And that is typically done by replication. Replication supports the upgrade path for the major version, so they support replicating an 8.4 instance from an 8.0 instance, and they will support replicating a 9.7 from an 8.4 instance. So typically what you would do is you would restore a backup onto a new instance and upgrade the instance in place to the new major release, and then you hook it up in replication. So what you then do is first you have to verify if your replication keeps up. Like if you're running your workload and the new version doesn't keep up in replication, that points to something wrong. So that's the first step you can do. And then later on, if your application is fine, you can start sending a portion of your reads to the new version to see how it behaves to your queries. And then what I always recommend if there's a new major version is first make sure that your backups are working in the new version before you upgrade everything to that new version. And if you verify backups, also verify restores, because if you don't test the backup, I kind of assume that you don't have a backup. And then finally, at the end, you can upgrade the primary to the new version, and your entire system will be upgraded. MySQL 8.0 introduced group replication, and for group replication, it's a bit more difficult to upgrade because you have to keep in mind that the version in the group has to be the same. So what you can do is the first way to upgrade is an in-group upgrade. So basically, you take one of the servers out of your group, you upgrade the server to the new version, and it can join the group again as a secondary. And then you keep doing that with all your secondaries until all the secondaries have been upgraded. And then finally, you remove the old primary of the group, and you upgrades the group to a new to have a new primary, and then the old primary you can then also upgrade and rejoin to the group. Important to notice that if you have a group of 3 instances in your group replication, you will lose the ability to withstand failures. Like if you only have 3 instances, that's the minimum for a group replication to be able to lose a node. If you take a node out of that group, you will lose that ability, so the high availability of your group is going to be compromised while you're upgrading. So typically what you would do if you want the in-group upgrade process is you would have more than 3 instances. The ideal number there would be 7, so you can upgrade 3 instances completely, so you still have the quorum there. Another way to upgrade the group replication would be the rolling migration upgrade. So basically you remove the group members one by one, and you create a new group with upgraded members. And then you set up asynchronous replication between the old group and the new. And then once you have the majority of your group upgraded, you start pointing your traffic to the new group, and then you can upgrade the remaining members. Also in this case, if you only have 3 instances to upgrade, it's always going to be a bit more dangerous because there's no more quorum and no more ability to lose anything out of the group. And then finally is the rolling duplication upgrade method. And basically then you create a new group with the new version. You set up the asynchronous replication between the old group and the new. And you start building up the new group. And once you have the new group set up to the number of nodes that you want, you can flip it over to the new group, and then you can decommission the old group. And that was kind of it. So, questions?
Are there any questions?
Hey, so quick question. I saw there was some deprecation around the SSL parameters.
Mm-hmm.
Is that just for naming reasons, or they're just changing the way you set up
They changed the
SSL?
name of the parameters, yes.
It's just a naming
Yeah.
change. It's nothing really.
It's the old --SSL parameter that they removed, and it's now the SSL mode, which you then say that you want to verify the CA, or that you just want to verify the server identity and those things.
Okay, cool.
Do you have any idea what percentage of servers out there are running 8? Do they know how many or what percentage of servers are running 8 versus 8.4 versus 9?
No, there's no statistics about that. So Percona does some telemetry about that in their version. So there you could maybe get some numbers for that, but currently there's no public data on how much people still are there. I know for a fact that there's still a bunch of people running 5.7.
One of our servers just got rid of it last fall.
Yeah.
And is there any other questions? Any more questions? If not, let's go ahead and give Matthias a round of applause. And thank you so much for joining.
Hello, hello. Is it coming through? Testing, 1, 2, 3.
Okay, so today we have Scott Strauss, and he will be going over Rest Assured, serving up MySQL REST service with nodes. Let's give it up for Scott.
Thank you, both of you. Thank you for being here today. I'm going to be talking about a relatively new feature that's part of MySQL. And it's something that I think is actually really cool. It's something that I have played around with a lot, and I can't wait for it actually to be baked into the full product. But before we talk about anything else, this is the obligatory I love me slide. I am a full stack developer. I've been a full stack developer longer than the term full stack developer has actually been in existence. Back then, we used to call ourselves developers. Before there was all the speciation, and now everybody came back into again, and now we're full stack developers. It was basically a way for people to say, we know you're doing the same job, but we want you to feel better about it. In the entire time I've been a developer, the only thing that's been a constant in my stack has been MySQL. I have been using MySQL since my first job as a web developer, and every day since then, I have had a MySQL instance in either production or for professional or personal use. I wouldn't call myself a power user, but I have been using it for a long time. I like to give things away, kind of like a bribe for people to come talk. And the fact that there's not many people here, you guys are in for a treat. So during the presentation, at the end of my presentation, I'm going to ask a question about something you saw or something I said. The first person to get the question right by raising your hand, don't yell out the answer, is going to win a dolphin. This one. Okay, so you got to pay attention. And then lastly, this cute guy here on the screen is my dog Murphy. Murphy is my best friend. He's the best office mate in the world. He spends pretty much all day, every day in my office, most of that time at my feet. And what makes him the best office mate in the world is when I'm trying to work through a problem, when I'm having coding a problem or trying to figure out a database problem, I talk to Murphy about it. And he looks at me with those eyes, and I get the solution. It's almost like he's willing it to me. So he's like, he knows more about databases and code than any other dog in the world. But this is Murphy 4 years ago. This is Murphy as the 112-pound beast that he is now. He is a huge dog, he's an affectionate dog, and he's just awesome. So this is our safe harbor statement, basically saying that anything I talk about today could possibly change because it's not a fully baked in thing yet. So what is the MySQL REST service? The marketing speak is a next-generation JSON document store solution that enables fast and secure HTTPS REST access to MySQL data. That sounds awesome, but what does it mean? What it means is we're going to be able to, and you can right now, and I'll explain how you can in a bit, be able to build RESTful services connected directly to your MySQL database. Okay? It's designed to have HTTP and JSON application access, so you could theoretically have an app that only serves HTML from the MySQL server, and you don't need middleware. It's possible. I don't know how practical that is, but it is possible to do that. Whoops. Oh. And it allows you to do that without SQL. And I'm not talking about NoSQL, where it's kind of SQL, but not really. Like you literally can just hit an API endpoint and get data back, or hit an API endpoint to insert data into a database, and you never actually have to run a SQL command to make any of that happen. And we can, through the REST service, we can expose tables, views, stored procedures, and stored functions. MRS follows a similar design principle to Oracle REST Database Services, or ORDS for the cool kids, which I don't think anybody's cool saying ORDS, but which has been around for a while, and we're kind of building on top. We're not building on top of it, we're following the same type of paradigm to allow similar functionality for MySQL that is allowed through ORDS. Initially, MRS, that's what I'm going to call it from now on because it's easier to say, MySQL REST Services, MRS, was originally available as middleware that was on MySQL Router. So in order to use this, you had to have an instance of MySQL Router running, and you would make the request to MySQL Router, and then MySQL Router would then pass those requests along to your MySQL server and get your data. But now, you can actually run MRS directly in a MySQL database instance without needing MySQL router. Right now, that's only available as a lab release, and the URL is labs.mysql.com. And when you go there, you'll log on and you'll see right now it's MRS 16, so that's the one that you want to grab. But I do want to point out two very important things on this screen. The first one says this is not fit for production. And in case that didn't make sense to you, it says, please do not use these binaries in production. I like how we use please there. Like, please don't do it, rather than don't do it. We're like, please, please don't. Keep in mind that this is something that's still being worked on, and it's not actually ready for general availability yet. I don't know how long it's going to take before it's GA, but it is something that we are working towards, and there have been improvements made in this over time. When you want to configure MRS, there's two ways you can do it. You can do it through the MySQL shell extension for Visual Studio Code, or you can do it through running SQL commands. You actually can run a SQL command that sets up not only the REST service, but creates endpoints and dictates what those endpoints can actually do and what data they're going to return. For this demo, we're only going to show how to do it in shell, because I'm a poor typist and there's no way I'm going to type any of these demos with people watching me. I will show you a way that you can see what the SQL looks like when you're done for one of the examples. So the first thing we need to do is we need to load the MRS component. The MRS component comes installed with the lab version, but it's not loaded. You just run this command, install component file component underscore MySQL underscore REST underscore service, and it will load the component and be ready for you to use it. Now again, this is going to be something you're going to be running locally, hopefully, not on a server somewhere that runs your production system. Before we can do anything in terms of setting up REST services, we need to enable it. And that's very easy to do in VSC, because when you load up the MySQL shell extension in VSC and you start it up and you make a connection to a database, you'll actually see an option underneath your connection. You'll see here it says MySQL REST service underneath localhost. You right-click that and then you click Configure MySQL REST service. Pretty easy. And then when you click that, you're going to get a window that pops up that's going to ask you for information. Oops. So the first thing you want to do is you want to enable it, because if you don't enable it, you can't use it, and then the whole exercise becomes irrelevant. It asks for the version, which I think right now 4.1.5 is the only option there. And then you can pretty much, for testing purposes, leave the defaults the way they are. Click OK, and then you have the REST service enabled for your local instance. So now that we have it enabled so we can actually start using it, the first thing we need to do is we actually need to add a service to our instance. And we do that again by right-clicking now we right-click the MySQL REST service. So this isn't on the local host that we did before, this is on the service that we just enabled. And you do Add REST Service. And when you click that, you'll get a window that pops up that asks you for some information. The first bit of information is going to be, what is the service path going to be? This is actually going to be starting at the root of your URL that you're going to use to hit the API. So after you have, localhost port blah 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 / this is what's going to show up next. Okay? You could actually leave that blank and just leave it /. But for this example, I name it my service or / my service. I give it a name. This is basically the way that it's recognized throughout the system, not necessarily by the path itself. The REST service flags, you want to enable it, again, because if you don't enable it, not going to work. I'm setting it here as the default, so there's going to be no other REST service here. Whenever we start dealing in this particular instance of REST service, it's going to use this by default. And then I mark it as published. If it's enabled and not published, not going to work. You're not going to be able to access the endpoints. Oops. And then down here for the linked REST authentication apps, there's two ways you can do authentication right now. One of them is through MRS, so you actually create a user through this interface that will allow you to access the information, or you can say, I'm going to use a MySQL user that already exists. For this demo, I'm using the second option there. So I actually have a user in my database that has access to this particular database. Actually, it has access to everything because it's basically my root user, which you don't want to do. I just did it for the demo. It is important to note that the authentication can handle OAuth. I actually haven't played with it yet because I haven't gotten to that point to try it. I've just been playing around with some of the stuff that I'm going to show you today, which again, I think is really cool. So now that we have the service enabled, we added a service called MyService. The next thing we need to do is we need to add a schema. So remember, in MySQL parlance, a schema is just the same thing as a database. So here what we're going to do is we are going to right-click on any of the databases we have on our server. Here I'm using the SCaLE database, which is a database that is publicly available that people can use for MySQL. It's a fake database of movies and actors, and I even think there's something about talking about rentals, so that gives you an idea of how long SCaLE has been around. So it's been like, probably like based off of like a Blockbuster type thing or whatever. Blockbuster is what we had before Netflix, just for the new kids in the room. So you right-click on the schema that you want to use, and then you do Add Schema to REST Service. And then you specify the service path that you want. So here we're saying we want to add the SCaLE schema to the MyService REST service that we created. All right? And then we give it the schema path. Now this is basically going to mean, this means that when we want to access this schema through MRS, we're going to be using /myservice/SCaLE. And that'll be the path to let us know that this is the schema we're working with. For the REST schema flags, there is enabled, disabled, and private. The only way this is actually going to work is if you do enabled. Disabled, it's as if you didn't enable it at all. Private it's handled internally, I believe. And you'll see then you can change the schema database name, but I don't know why you would right-click on the schema and then change it, because that could lead to confusion. And then you click OK. So far, so good. Very, very easy. Now, the last step we need to do is we actually need to add a table to the schema that we added to the service. And we do that by opening up the schema that we want, right-clicking on the table that we want to add, and then click Add Database Object to REST Service. Again, very easy, it's very intuitive, it's very well thought out. If you understand the steps that need to be done, it's very easy to figure out and remember what it is that you need to do. Now here we get a little bit more of a complex form. There's a little bit more data here, a little bit more stuff that's going on here, because this is like the meat of what we're doing. And what you can do is very, very granular. So starting off, we're saying we want this in the MyService service path as part of the SCaLE schema path, and then we're giving it the object path of actor. So if you think of it in the way that the service is like the top tier, and a service can have multiple schemas, and a schema can have multiple tables. So you can actually have a single REST service that provides information for multiple database schemas, and then multiple tables underneath each schema, or views, or however you want. And then you need to enable it. Now, if you check auth required, that means that you're actually going to have to use the authentication spec that you chose initially, whether it was MRS or was the MySQL user, to authenticate before you can use any of the features. If you leave that unchecked, you can list only. So if you uncheck auth required and you still allow insert and update, you can't insert and update unless you have authenticated. So the auth required is only for anything that you're going to list. And then here, this to me is the fun part, because what you can do now is you're dictating which data is going to come back when you call this REST service, and which data can be managed. So here, we're saying that we want the actor ID first name, last update, the film actor ID, which is a foreign key to another table. And then in that table, we hit the film ID, which is the foreign key to another table that actually has the film data for the actor or for the actors that we're going to be dealing with. And in this particular case, you can't see it here, but I picked title, length, and I think date released. So when you set up your schema here, when you set up this particular object, you can dictate which information comes back, and you can keep going down the tree of foreign key relationship as much as you want, and that data will be returned. Now you got to be careful, because if somebody has 1,000 films that they're tied to, that's going to cause problems down the road at scale. But for this demo, I'm like, let's just do it all. See what we can show what happens. And again, this is fairly intuitive. The first time I used this, I was able to pull in, I figured out what the stuff was without looking into it. And I was able to be like, oh, yeah, if I click this, and I can get that table. And if I click this, I can get that table. Let's see what happens. Holy crap, all the data came back, and I didn't have to do anything. It's pretty cool. So then you can determine what you want to do. Whether you want if you want to add insert, update, or delete. Everything that you do so far, it's all based off of listing, so it's based off of selecting. I actually had to go in and enable insert, update, and delete for this particular endpoint to make sure. So by default, you're not allowed to make any changes. You're only allowed to read. You actually had to go in and check those, and you'll see they'll be dark, like they'll be black with the white letters before you select them. And then there's icons that are next to each column, and I'm not going to go into each one because they're all they're kind of hard to see. But the one that looks like a document with a down arrow is saying that you can actually sort on this column. So you can actually make a call to a REST service that includes how you want to sort the data. And if you have a column that isn't part of that, it's not going to do anything. It won't throw an error, but it won't do anything. So if you pass in, I want to sort by the film ID, and there's no way to sort on the film ID, you won't get an error, it just won't be sorted that way, okay? There's other information where you can actually say can't delete, can't update, stuff like that for those particular columns. And then remember, that's based on the column, not the table. So up here, the insert, update, delete is for the table. Here we're talking about the specific columns. So you can actually have that type of granular control where you can dictate which columns can be sorted on and which columns can't. And then there's this nifty little button called SQL Preview. Anybody want to take a guess what it does? Previews the SQL. If you click that button, you'll actually see the SQL query that would be used to generate this database object in the REST service. So if you just ran this without doing anything else, it's going to throw an error because it's not going to know about the REST service being enabled or the or the schema being added. So this was just to add those particular items that I showed you on to dealing with that particular table. And if you look at this thing, you can actually see where the relationships are and what's allowed. So you see it has @insert, @update, @delete. That's showing that we can actually do those particular procedures against the table that we're using. So that went a lot faster than I anticipated. It's demo time. And I'm actually going to create a REST endpoint live. Because I can click a mouse like it's nobody's business. So you'll see here we have this. Now this is actually the same instance that I grabbed those images from. Okay, so you see we have the actor. The users is there because I needed that to log into the application, and I'm going to show you momentarily. But I want to add, hold on, before I do that, I want to show you, here is an endpoint. You can see up top, I'm looking to just list staff, right? And I'm doing this to show there's no smoke and mirrors. I'm doing this live. If I click send here, it says not found. That's basically saying the endpoint that you're looking for doesn't exist. So if I go back over to here and I find the SCaLE database, which is right here, and I right-click on staff because that's the one I want to add, and I do add database object to REST service. Come on. All right, hold on. Sometimes this is a little, you got to do it a couple times, or if the window's open. There we go. So now we have the window where we can say, you know, we have staff, first name, address. I know for a fact I don't want picture because that puts up a lot of data that makes it hard to read. We also don't want the password to show, even though I think it's hashed, it shouldn't matter. And I'm going to get rid of last update. And the other thing I'm going to do for this particular demo is I'm going to get rid of auth required because I didn't want to have to sit there and try and log in through Insomnia to show you this demo. So remember, when auth isn't required, you can always list. You can't put or up, you can't insert or update or delete. So then I click OK. And now if we scroll back up, we'll see that staff is now one of the tables that's part of this schema. And you'll also see that it's got a slightly different icon. There's a small yellow icon that lets you know that it's being secured. So that's basically saying that for the staff, you don't need the authentication. So now if I go back over here to the same endpoint and click send, now we get data back. Okay? So you see it has the email. The cool thing, this to me is really cool, and I thought this was a very good idea. Whenever you list something, there will always be a property that's returned called links. And those links, in this particular case, is telling you what link you can enter in to get the information for just this specific user. Okay, so if I go to the endpoint, my service, SCaLE staff 1, I'm going to see the information about Mike Hillier. Okay, and I'll show you that in a second. So you see here we have items, and we have the store ID, and you know here's John Stevens, and it shows he's active, and his staff ID and the store ID. But if I go up here and just do \1 and send it, now you'll see we just get a single object with just Mike Hillier's information. And I didn't write a line of SQL to make that happen. It is pretty fast. It happens pretty quickly. Again, it's a small data set running on my laptop, and I'm just making one request at a time. But the fact that it still comes back pretty quickly. I haven't done any testing of this on SCaLE or any type of load testing to know how it holds up. But considering the fact that everything takes place on the back end on the MySQL side, it's going to be as performant, at least as performant as what the database is itself. Okay, and if you notice. That was what, 3 mouse clicks, 4 mouse clicks maybe, and I was able to expose that table. Now granted, yeah, there was a little bit of setup because I created the service, added the schema. I didn't want to do all of that live during a demo, but it just shows you how quickly you can get up to speed with stuff. Now what I like about this, and let me get back to my slides here. Oops. Oh no. Andrew, you get to see the slides you missed. You getting this? See, this is when I have all those neat little animations where it becomes an issue. Okay, add a table. Okay. So some of the advantages of using MySQL REST service is you can actually perform CRUD operations with no SQL. You don't need to run any SQL queries to be able to insert, update, read, or delete data. Or complex ORM mappings, because I was talking to somebody once and they're like, well, you could do that with ORM. Well, yeah, if you have a PhD in like hieroglyphics, because that's sometimes what it takes to configure ORMs. ORMs, here's the thing, I don't want to badmouth ORMs. I like ORMs, I've used them before. They are very good for what they're designed for, which was basic CRUD. When you start getting into complex relationships where there's a table that's related to another table with 4 tables in between, managing that becomes very, very difficult with ORM. Especially like Hibernate can get Hibernate's great. I love Hibernate. But when you start getting complex relationships, the configuration is difficult and the queries that Hibernate generates are not as performant as if you wrote them manually. Okay? Just something to keep in mind there. it eliminates the need for middleware. Okay, as I said, you can actually, and I didn't show it in the demo because I didn't think I was going to have time, and now I wish I had done it. You can actually configure the REST service to return HTML. So you can actually have an HTML page that's in the database or as part of the REST service, and then when you hit the REST service, it loads the HTML or loads the JavaScript. So you could have like you could basically have a static page that pulls that information down, displays the data, and then allows people to start iterating through and doing the stuff by hitting the APIs that we just showed. I don't know if that's necessarily a good idea. I don't know if that's how I would do it, because if you start getting into a lot of different users, one of the things that I've heard is people say, well, if for each user they should have their own MRS user, which now you're talking some systems that they have millions of users, now you have millions of users in your database, determining who can access what. Now there is a way with the security you can determine roles. So you can actually create a user, assign it to a role where they can only read, or they can only insert, they can only update, very few people can like delete. Okay, so there is a way to do role-based security with that, but still when you start talking that many users at scale, it becomes a little bit more difficult. So what is more likely the case is you actually have some type of middleware set up like Node, like I'm talking about, where you have Node connect to the database using the singular user that you created, or users if you want to have different permissions based on what's going on, and then use that particular session from the database for everybody else, including logging the person into the application, which I'm going to show you in a second. There's no SDK or connector needed, which is good because if you're working with a language where you need an SDK or you need a connector or an SDK, they're usually third party. Okay, we do have some connectors that we offer. The Node connector we offer is not necessarily the best one that we have because the Node connector is specifically for using document store or the XDev protocol, which we're not using in this demo because I wouldn't use this demo. I use the MySQL 2 connector for Node applications, and that's the one where you can actually just write raw SQL. All right? And you can use, in this particular case, native JavaScript features to call the API. So you can now insert data into your database just by using fetch, or by using the XML HTTP request, which I don't think anybody uses anymore, but it is something that you can think of. So imagine that like if you have a form where you collect the data as JSON, you just call an API and pass it in. Now you just either updated or inserted a row into your database. Again, without any SQL. The advantage of that to me is the fact that if you have somebody who knows about the database and can set up the REST services in a way that makes it intuitive for developers, your developers don't need to know a whole lot about your schema. They just need to know what data is coming back and what data they need to send. They don't need to know what tables are going to. They don't need to know, they really, honestly, for the most part, don't need to know data types. They just need to know, you need first name, last name, here it is. And there's a lot of developers out there who know how to make API calls who could not find their way through a database with a flashlight. Okay? And there's nothing wrong with that because you know what? Some people like databases. Ew. I'm not one of those people. I love databases, and I still love this feature. I still find this because I'm a developer, and I'm like, holy crap, this is so much easier than, trying to figure out the query to use and, and what tables to use. Now, granted, in this particular example, there's only like 6 tables. But if you had a system where there were dozens or hundreds of tables, having these API endpoints like this can really mitigate the time it takes developers to get ramped up and working on your system when they don't have to worry about writing queries. They can just say, hey, I need an endpoint that does this. And then the person who's in charge goes and makes that endpoint. So here's some code examples to show you the difference between the two pieces of functionality. And I'm going to admit, I purposely made the SQL one more lines of code because I thought it would be a cool little demonstration. But the first thing you need to do in this particular case is you need to import the third-party library that you use to connect to MySQL. And here I'm saying we're using MySQL 2. Then we need to create the connection. And when we create the connection, we pass information such as the host, the password, the user, the database. You also, in this particular case, can start adding information about thread pooling. which, by the way, is something you don't need to be concerned about as much when you're using the MRS, because you don't have to worry about the connection between the middleware and the client staying connected. You're just constantly making calls. You're constantly making an HTTP request. And in this particular case, we're setting variables for the actor and for the actor's first name and last name. And then we have a, we call connection.execute and pass in the query and parameterize the values. Something else you don't need to be concerned about when you use MRS is you don't have to worry about parameterizing the values. Why? Because when you create the JSON string that gets sent to the server, it's already parameterized. So it kind of can help mitigate SQL injection. I'm not saying it's going to get rid of it completely, but you know, if the server knows that this particular value is a string and to always treat it as a string and not as a command, you kind of limit the risk of being exposed through SQL injection through that. And then on the flip side, you see we just do a fetch. And we pass in the URL, which in this particular case, it's localhost 33060 to myservice/SCaLE/actor/1. You'll see the method is put. That means we're going to be updating or inserting this information. Actually, it can mean we're updating it because we're passing the ID. We do have to add headers to say that it's the content type is application JSON and the authentication, the authorization. So when you call the endpoint that logs you in, you will get a token. This is the token you will use for all your other requests during that particular session. And then we do body, JSON.stringify, first name, last name. So this is actually going to say, hey, this user's name is John Doe. Now, I will admit, to some people, the first part is probably easier. But for a lot of people, the second one is probably easier. Because a lot of JavaScript developers, a lot of Java developers, a lot of PHP developers and Python developers, they know how to execute, or they know how to call APIs. All they need to know is the path and what data is expected. That's all they need to know. And if you know that, then that's a lot easier than trudging through the database to find the table, to know what where you're going to be inserting data, or how you're going to write the query to insert data, or if you're pulling information back, what tables are related to get this information. Because sometimes there are foreign key relationships that are related to tables that kind of sound like what you want, but they're not. You actually needed something else. But if you have somebody who knows the database, who sets up the service, then here's the thing: as a developer, that's not on you. That's on them. Oh, look at that. I didn't think I did that. My bad. So, it's demo time again. Now I'm going to show you the web app that I did, which, here we go. And let me make this full screen. So, hopefully the session would have timed out. No, the session didn't time out. Oh, well. Oh, wait, I can log out. There we go. So I'm going to log in here, and what I'm actually doing here is I'm not logging in using the credentials from the MySQL user I specified when I created the service. This is actually going to be a user and password that's in the users table that I was showing you, and there's actually an authentication process that happens on the node side that is like, hey, go run this endpoint. And let's hope it works. Yes, it works. So now we have logged into the application. We have a list of actors. We can create a new actor, call him, Skip Dingelhofer. Little thing I like to throw out to people is if you're ever in a database and you see a user named Skip or Skippy Dingelhofer, I was probably working in that database at one point in time, because I had been using that as a test user since day one of my first job as a developer. So now if we go over here and we search for Dingle, or I'm just going to do Ding. Oops, I hit the wrong button. And then I hit search, you'll see that we have Skip Dingelhofer and we have a Skippy Dingle. And then if I want to edit that to say, you know what, we want to do Skippy Dingelhofer, and click save, and then we can go back and Search for Dingle again, and you'll see here that it's now Skippy Dinglehofer. Okay? So just for those of you who were paying attention, I logged in, listed the actors, created a new actor, searched for that actor, updated the actor, searched for the actor again, without one SQL command being run. All of that, everything you just saw, was done using the MRS APIs. Now, I feel kind of guilty that I put, with Node in this title because there's very little Node code to talk about in here because all we're doing is writing APIs. And I figured that's something you could learn how to do. You don't need to. So it was kind of like a hook, like, hey, if you want to know how to do this in Node, here, look, this is how you set everything up. Oh, and by the way, just use fetch. So you don't really need to be overly concerned about how to actually access the API, as long as you know what the endpoint is and what the data is expected if you're doing a write operation. It doesn't matter whether you're using, an API from somewhere else or an API from MRS. It's the same procedure. You use fetch. You use the right headers with passing in the right authorization token. You pass in the right data, and you will get the results that you expect. Again, I think it's very, very cool. I don't know how much it'll be adopted with bigger companies that deal with like terabytes of throughput. I don't know how that would scale for that. But I think for most people, for most companies, most applications, this probably is going to be a good fit. It's probably going to be a good way for people to access things easier. And the cool thing there is you can kind of treat your front end as if you're dealing with documents, like as if you were sending information to or getting information from, like a document store like Mongo. Because as far as the front end is concerned, it doesn't matter what, because the same thing, when you're using Mongo, your front end is going to send information in a certain way, and then Mongo's going to handle it on the back end. Very, very similar concepts. You're just hitting a different endpoint. So if you have an application that uses Mongo, you're going to have a get, a put, possibly a patch, and a delete endpoint that you can use to manage those documents. And it's going to be the same process here, with the advantage of the fact that your data is now stored in a transactional relational database rather than in just a blob, NoSQL database. So I know you guys have gotten the spiel, but for you, because I don't remember seeing you today, whenever we come and talk at conferences, my team is actually allowed to offer, forget training exists in that slide because it changed and I didn't realize it. We actually offer free certifications for MySQL. You can get up to two chances to take an exam, and it won't cost you a penny. If you're interested, you can either see me after. Actually, probably be easier if you came to the booth, because I can scan you and then keep your information with everybody else's. Something to keep in mind that I don't know if you guys got is once you get the notification that the credit has been applied, you have 3 months to use it. That doesn't mean you have to take the exam in 3 months. It means you have to apply the credit. Think of it as a coupon code. Your coupon code might expire on Sunday, but what you buy with the coupon code will last for much longer. So you can, I don't know how far in advance you can schedule the exams, but if you have the ability to schedule it more than 3 months in advance, then you could do that and not have to worry about it. And with that, a little short on time. I should have put that other stuff in there. Does anybody have any questions? Yes.
And I was thinking that this is actually a great way to gate premium features in a plugin. Like if you have your own server with MRS on it, and you have specific things that you want to keep, like so you have a freemium model, right, where you have the free plugin and then you've got the pro plugin. You can have this, so like it's not denied by WordPress.org, since you're gating something.
Right.
And you have the SQL on your own server somewhere.
Yes.
And you can completely have an entire full feature REST endpoint.
Yep. Absolutely.
Seriously, genius.
It is so I don't know, Andrew, if you heard what he said, but he works on plugins for WordPress, and he said this is a great way that you can actually integrate other services outside of WordPress in a separate database by using this, because WordPress isn't going to know you're using SQL.
Yeah, because WordPress will deny it immediately if you
Right.
have like a paid feature, that's built into the free plugin.
Yep.
But if you create, an exterior, something else external that it calls, they're not going to care.
I will say that there's a chance you could be violating the terms of service there, so be careful with that.
Okay.
But
Yeah.
I do think that is a nifty idea. I just don't know
Yeah.
how it's, and it really is to me. I thought I like our document store. For those of you who don't know, we actually have a document store that is similar to Mongo that stores the data in JSON documents, but it's in a relational database table. So you get all the benefits of like InnoDB in terms of speed and stuff like that with a document store. But I think I like this better now. I don't think this is a replacement for a document store because, again, you have to have the tables mapped on the back end to where this data is supposed to go. It's not going to be schemaless. There still is a schema. But like I said, it is you can kind of treat it that way because you're only dealing in JSON. You're only getting JSON back, and you're only sending JSON in. So it doesn't matter what's on the back end. For most developers, they're not really going to care. It really is, and the fact that we've been able to take it from putting it into Router and actually making it a part of the product now, so you don't need Router, because in some instances Router might not be an option. It really is. It's a nifty feature, and I'm really excited to see where our engineering team takes it.
Another question.
Sure.
Authentication. Are you stuck with, like regular SQL authentication, or can you use something like JWT?
It does support OAuth.
Okay.
Yeah. I don't know how. I haven't played with that yet, but I do know it supports OAuth.
Because that's even better for a plugin.
Exactly.
If you have a
Yeah,
license and then JWT authentication.
Yeah, it is. It's really cool. Like I have a database that I use. I manage a golf league. And if anybody's ever been to a talk of mine, I talk about the golf league all the time because I think it's a great data set to use for examples and stuff. But I've been using the golf league. I've been managing the golf league for over 15 years, and I wrote a web application because I got sick of using Excel, and then I found a WordPress plugin that kind of worked but didn't really fit my needs. So I actually wrote an entire web application that manages the golf league. And I have used that in my personal examples for doing MRS. And because there's some complex relationships in there, because you have a league, each league has a season, each season can have one or more divisions, each division can have one or more weeks, which is, that's the schedule. Each season can also have one or more teams. Obviously, you need to have more than one team or else it seems kind of stupid. And then there's a schedule, so the teams play each other, and trying to get some of that stuff. Some of the queries are pretty complex. And I've tried reproducing them, and it actually does a really good job of pulling the information back that you want. And you can actually pass in, I didn't show this because it was I didn't think it really fit, because I didn't want to go that deep into it. This was kind of like hey, let's see how interested you are, and then you can learn this. But basically, when you call an endpoint, like if you call actors, and you want to filter it by the first name, you actually URL encode a JSON string that says, you do Q equals, or question mark Q equals, and then you pass in the JSON string, the encoded JSON string for order by, first name, descending. And like as if it was a JSON, so you generate the JSON for that, and then you encode that as a URL encoded string and pass that to the server, and then it knows to sort by the first name or the last name. And you can also use that for pagination. So you can actually pass, so if you have a list of, you have 100 users and you only want to show 10 at a time, you can actually pass in that JSON blob or that JSON string, encoded JSON string, to do limit and offset to be able to paginate the data.
I just see so many uses for WordPress.
Oh, so do I. When I was putting this demo together, I was like, oh man, there's so many things I can think of that are cool.
Just because you have so many users in different scenarios and different builds, and you can set one SQL database that everyone connects to.
Yep.
And they don't have to have it locally. It's amazing.
Yeah, and the fact that it's so easy to, you saw how easy it was to create that endpoint. Yeah. Again, you could write the SQL for that, but I guarantee you it would have taken me a lot longer to type out the characters and look up all the different options that need to be done. rather than doing VSC. And I don't like VSC. I'm not a fan of VSC. I shouldn't say I don't like it. It's not my favorite. Okay, I'll use it if I have to, and I can muddle through, but I prefer IDE, or IDE, I prefer IntelliJ, IDEA. But for this, it's so easy. And there's another option. Let me see if I can, I don't know if I can show it. Let's see. I got time. So if I right-click on the service, I thought there was a way you could get all the information. Like there was a way that you can actually generate, maybe it's on the service. That's probably what it is. Copy to clipboard, create REST service including docket database objects. So if I click that and then open up a new file, which I forget how to do here. Oops. I forget how to create a new file, but I can't paste it in here, I don't think, or can I? I can. So now here, this is the SQL script that enables the service, adds the schema, and adds the database objects to the schema. So if I was to take this to another MySQL instance that had the MRS component loaded and ran this SQL script, all that stuff that I just showed you would be available. So that's how you can actually get it so where, okay, it works on my laptop. How would I get that to work on a remote server when you should put it in production? Don't do it now. And that's how. And you can actually, at that point, you can actually put the script.
When can I do that?
I don't know. And if I did know, I couldn't tell you. I don't know I can't even give you like a rough estimate. But trust me, when this becomes like GA, I'll be blogging about it.
I'm subscribing. Well, give me your blog.
Blogs.oracle.com/MySQL. Any other questions? Oh, wait, I forgot. I got to give something away. So if you remember, in the beginning of my talk, I said I was going to ask you a question at the end of the talk about something I saw, about something you saw, or something I said. And the first person to get it right wins the little dolphin. So the question I have to ask is, how much does my dog weigh? Ooh, so close. Nope. Go ahead. Nope. You know what? Dad gets it. He's closest. 112. And if you guys don't have any other questions, thank you for coming. Sorry I was a little short on time, but I hope you guys got enough out of it to be, intrigued. God, now I could take this off because it's annoying.
There we go. Oh. Let's see. A little loud. Hopefully it has enough battery here. I'll have to be careful not to use teacher voice or I'm going to wreck somebody's eardrums. Okay. My family pronounces the C like an S, so Wisławski, kind of like coleslaw. The Polish is Wacławski. I go by Phil. I'm not, yeah, Wisławski. I try not to be too evil to my students. I mean, little evil, but not too evil. Okay. Yeah. Okay. I think it's, huh? It cooled off the past couple days, but yeah, we've already had some days in the 90s. Oh, yeah, no, the summers in Arizona are a lot like winters in Michigan. You hide inside, you run out to the car and either turn the heat on or the AC on, and then you drive to the nearest appropriately temperature building and run in. You know, this time of year it's not too bad, but once it hits June, July, August, most of September, a lot of October, it's just, yeah. I believe so.
Hello. So today we have Phil Wisławski, and he will be going over 25 years in education, promoting Linux open source and MySQL, and he is currently doing computer information systems faculty at the community college in Mesa, Arizona. So let's go ahead and give him a round of applause.
Thank you. So David Stokes, who's actually given a few talks for my classes, convinced me to do this talk. And I was trying to think of specifically what, because I do use MySQL heavily and open source. So I figured just kind of doing a summary of what I've covered over the years. Now, it doesn't look too bad on my face, but yesterday I was at my dermatologist and she gets out the nasty little freeze ray gun and has blasted 3 small spots, thankfully, on my face before she asks, oh, hey, do you have anything coming up? Yeah. Typical disclaimer, I am technically, of course, this is part of my faculty professional growth, but I am not officially representing Mesa Community College or the Maricopa Community College District. This is just based on my years of experience and from my perspective. So, some of the goals of this talk. It's been a long, strange road trying to convince colleges and even high schools sometimes to use open source. I'll talk about some of the strange things we did as a college back when, you know, security wasn't necessarily a big deal. And there were definitely some challenges promoting open source. I got a lot of interesting comments from people. You've probably all heard well, why don't you use a real fill in the blank instead of the open source one? And I'll show you how I use open source or some of the tools I use in my classes, and explain how MySQL fits into all of this. And then maybe try to discuss the future. This is the part that's really in flux for community colleges right now, and high schools. Things are changing so much. You have, well, we'll get to it, but just the AI revolution, nobody necessarily knows what to do with it yet. Now, I always like this picture. I tend to inflict puns on my students because I figure I'm actually a closet comedian who wants a captive audience. The difference is you guys have chosen to be here. So, a couple bad puns. My original background, I was going to be an entomologist, a tropical entomologist studying insects. Now I do that type of stuff as a hobby, though I will admit I'm looking more at ocean invertebrates now than that. But I always told my students I've just gone from hunting one type of bug to another. And this one will take you a second. The people who can't distinguish between an entomologist and an etymologist bug me beyond words. There you go. So, my bachelor's of science was at Michigan State University in biology and entomology, though I did quite a bit of work with computers. My master's of science, I ended up building some of the lab equipment, programming the data loggers, and of course did a fair amount of work with things like SAS and other things like that. Depending on how you define it, I've been teaching for over 30 years. I started out as an undergrad biology lab assistant, just helping around and trying to keep students from killing themselves or killing me. My favorite had to be you would tell them not to do something. You turn around and somebody's got this steaming, boiling beaker of benzene and they're putting it under your nose and I've got contacts and I'm worried I'm about to melt them to my face. And that type of thing is a little bit safer with the computers. The worst they could do is crash their system and they get to reinstall it. I was a graduate TA for a while, did a variety of things in that. And then I became an adjunct instructor in the community college system in the Phoenix Valley, doing mostly biology, ecology, anatomy, and physiology. And then I became a Linux and HTML adjunct instructor. And then I finally became full-time in 2001. I got my 25 years of service this past December, and people are already starting rumors about me retiring. You gotta love it. And I've also done a few multimedia madness summer camps where just using open source software, things like GIMP and Krita and Blender and a whole bunch of other little tools, and we make some really cool presentations. And we've got this neat little planetarium that uses projectors and a computer at MCC, so they put it up on the big 30-foot dome at the end. Kind of miss those. And I always like to do the joke with my students. I started back in the 1900s. And so yeah, if you notice, it's like if hungry, eat, else sleep type of thing. So my early history. Back when I was at ASU, I got interested in this weird thing called the internet. It wasn't really graphical yet. But they had a VMS, I think it was a VMS, maybe it was a VAX, it's been so long, sector not found. But I'd chat with folks and have fun. And eventually, of course, they found out that I was no longer a student and they cut my account. And there was a company in the Valley called PrimeNet, but they really pushed you to use Linux to connect to it. I never heard of that, so I downloaded the 32 individual floppies. Yeah, the 3.5-inch ones, and installed them in. When Walnut Creek came out with the CD and CDs came out, it's like, oh, this is so much better. Because downloading 32 floppies and labeling them and making sure none of them gets damaged. Now, PrimeNet would they kind of got bought out by a more commercial interest, and they were upset because I was running a server on it. So they did this little thing, well, you know, human beings need at least 6 hours of sleep a day, and you've been on 24 hours a day. So I just set up a little cron job that hung up at 3 a.m. and dialed up at 9 a.m. and no problem. So yeah, I ran a 28.8K baud modem and played around, played around with a lot of different things. And we did a summer camp as a group where we're going to do machinima. And they decided for some reason I was a gamer, which at the time I was not. They bought me a copy of WoW and said, learn it, because there's some really good tools for that. They, however, still refused to pay my monthly fees. But I kept a copy. I figured I was okay because, I'd done it on Windows and games don't run on Linux. And the very last Linux World Expo, which was horrible, all the good talks were canceled and the other ones were, here's how you convince your boss security is important. So I got so bored that I played with a copy on my little copy of Ubuntu, and oh crud, World of Warcraft ran on Linux in 2008. And I'm still playing it to this day. Early on, I would just apply patches and compile kernels for fun. And looking back at it, it didn't really do me any good in most cases, but it was something that I could say I did, and it took like a couple hours to compile them sometimes. I use it heavily in my day-to-day. All my laptops are some flavor of that. I've got a couple little mini PCs. I've got my servers, which I'm switching over to Alma Linux after Red Hat, CentOS did their little thing. I scuba dive, so I use Subsurface, which was written by Linus Torvalds, but he's no longer in charge of it, to keep track of my dive logs off my dive computer. And SCaLE 10 was my very first SCaLE. I used to still have the hat for it. I got lost someplace. So, again, I'm going to have to be very careful. This microphone is very sensitive. Right around 1994, I started teaching as an adjunct at the community colleges in biology, anatomy, and physiology. And 94 is kind of an interesting year because, yeah, the World Wide Web had been out, but this was right about the time where some of the first graphical browsers started coming around, and CDs were more common. So you were starting to see more multimedia even creep into biology, anatomy, and physiology, slowly but surely. And of course, because I was still playing around on this Linux thing, I needed to learn more about it. The very first time I opened up Vim, I had no idea what it was, and I'm hoping nobody else did this, but I wasted like 30 or 40 minutes trying to figure out how to delete all those little blue squiggles that were on the screen. Oh, well. So I took a Unix class with a gentleman by the name of Greg Swan, great guy. And I chatted with him a lot, and so he invited me to teach the class. And I then later helped develop some of the very first web and internet classes for that as an adjunct, and even did a couple web development classes with Perl. It has been long enough now that I remember a few things about Perl, but the main thing I remember is I'm glad Python exists. I may be a little biased, but oh well. I then, of course, as I started teaching, I gave my students accounts on my server so that they could do stuff in the class rather than having to use the school one, which was not always going to be as up to date. Plus, I could let them host web pages. Now, of course, you can all think of some potentially interesting side effects to that. My favorite had to be one morning, I'm hearing a phone call. I'm going, oh, it's 9 a.m., I'm not up for another couple hours. This is so-and-so from Security Services on behalf of Chase Manhattan Bank. One of the users on your server is running a phishing scam. I teleported out of bed, grabbed the phone, and said, hello. Let me go check. I logged in, and one of my students decided that it was too much trouble to create links and click on them and then fill out the forms. He just created a little interface page. The only thing that saved me is that the domain name was so far from Chase Manhattan Bank, I got to keep all my computers. And I had to explain this to the student. And he said, oh, I'll just do it at home. It's like, you don't understand. This is throwing up huge alarms at this company. It's cross-site request forgeries. And it's like, oh my. He eventually figured out it was a bad idea. Then, of course, I wanted to teach a Unix server class, and I kind of helped develop that. Again, pretty primitive to what we do nowadays. Problem is, we couldn't share a system. If you have 30 beginners administering a Linux box, it's dead. I mean, heck, to be honest, considering how opinionated most admins are. You put 30 different admins with the same level of access, and they're going to keep undoing each other's changes till eventually it's dead. So I had to convince a dean to let me install Linux on their precious Microsoft Windows machines. Went around and around. I said, okay, as long as it runs on Windows, no problem. Freaked when I said it was instead of Windows. Now, to be fair, we had a couple of odd things that did make this a little risky. Our school at the time, which we were a fairly big school, but our entire internet was one single bridge. That means that every device had access to every device. So much so that when I did set up my home server and students wanted to print, well, the HP printers in the classroom used Jet Direct cards. So I just configured my remote server to print to the printer in the classroom because there was no security. Again, 90s, things have changed a lot since then. But I still did occasionally have students who weren't very careful, and we got yelled at. They wouldn't use the proper IP range I told them to, and they would just literally go to some poor Windows machine, smack it upside the head, grab its IP address, and the person's going, what do you mean I'm disconnected from the internet? Okay. Now, one of the things that I ran into, and I haven't heard this as much in the past 10, 15 years, but I heard it a lot whenever I suggested using open source, save money. You get the deans and the administrators, whose neck do I choke, and it better not be mine. Because, and you also hear the, nobody got fired for, buying Microsoft. Well, of course, you could always blame Microsoft. In fact, that was one of the reasons people kind of hated Linux, is a lot of the hardware vendors would go, oh, that's just a Microsoft problem. Well, when you started putting Linux on the same hardware, people were able to show, no, your hardware is messed up. I think that was one of the reasons why some of the early hardware folks didn't like Linux, because they couldn't use the, oh, it's Windows. I had one faculty member, she was a great teacher, but she was convinced that we were wasting all this time and effort on Linux. At least once or twice a year, she'd come with some sort of news article about how Linux was going to die. And I think she did this until just about 2 years before she retired, every year. I think I finally, when I pointed out that IBM I think it was IBM made like $1 billion on it that year, they went, oh, well, maybe it's real. But yeah, no, it was quite interesting. So I needed a plan B. And with the help of a friend, I built a custom boot floppy and used, anybody even know what these are? They're Jazz cartridges. They have 1 gigabyte of storage. The drive is about this big, and it's got some weird form of SCSI cable connection. But they would let me put those in there. The problem is that the boot floppies, and yes, we were booting off a 3.5-inch floppy for Linux, didn't have SCSI support until you boot it up, but we couldn't boot these things up because we didn't have SCSI support. So I had a friend who knew a little bit more about Linux at the time than I did, help me put in SCSI support into the custom boot drives. So they worked, but the cartridges were like $100 back in 1995. And after a couple hours of running, when you popped them out, you had to be careful. They were hot. A lot of heat there. And of course, later we finally got removable hard drives we could check out to the students, but then they'd have to at least, buy the bay to use at home. I wanted students to be able to do it outside of the classroom. We then did VMware. We ran into some problems. I think it was VMware or VirtualBox. I think VMware never had, in the early days, a free version for the Mac users. And with community college students, there's only so much you could get them to buy. And then finally, many, many years later, and this basically was probably about 2018, we finally got a membership with the AWS Academy, and we could use that. I mean, I'll admit, having dealt with their billing system, it is the biggest voodoo ever. But for just using it with the students, it solves so many problems. Mainly, it took our district office out of the equation entirely, and it worked much better. And then, of course, as time went on, there's several times where I helped develop things, and then we hired somebody full-time to take it over. Some of you may or may not have met Dennis Kibbe. He was a big one in the Phoenix Linux Users Group, and he's given talks here. He got hired on and focused on the Linux courses and built it up, and as of January 3rd, 2017, we became a Red Hat Academy. That's a big improvement from, why are you using Linux? Use a real OS. So, Python. And you're going, wait a minute, still no MySQL. We'll get there. Taught a few sections of a very primitive web development course using Python. It's long since been removed. They decided to get into the gaming. Gaming is a big deal, so we're building a gaming associates. Well, we ran into a problem. As we are a district of 10 colleges, our instructional council is made up of the 10 colleges, and you have to get at least 7 of the 10 to vote. And we wanted a programming prerequisite for the intro game course, but they said you can't have a significant prereq for a 100-level course. So I basically used Python and Pygame when I first taught it, because you could learn the basics in a few weeks. I mean, basics, you're not going to be powerful. They could, after that first few weeks, do some fairly fun little text-based games. Some students are very creative. Few of them may need therapy, but that's a whole different issue. Some of them were fans of a game, I Have No Mouth, But I Must Scream. Look it up sometime. It's an interesting game. And then we'd use Pygame. Okay, so MySQL, finally. I used it in nearly all of my web classes, because if you're going to do PHP or even JavaScript or whatever, having a data store works, and we had access to one. I give each student their own little database on the system and work through that. We used it with PHP, JavaScript. I created a simple PHP API that they could call using Ajax. And of course, we developed Python level 1 and 2 because it became more of a serious language. This was another one where in the gaming class, I constantly went, use a real language. And it's like, well, what do you want me to use? C#? Okay, and what's the gaming environment for that? At the time, it was something called the XNA Developer Studio. C#. You could argue that the reason why it exists is a little petty, but it's a solid, good language. The XNA Developer Studio, I can't say anything about it because if you can't say anything good, don't say anything at all. It was horrible. We did that for one semester. C#, great language, but to learn the basics, because nobody had programmed before, and build a game in it, that just didn't work. Went back to Python. And of course, eventually, we had a full-blown MySQL class because databases were becoming more important. And they realized that while Microsoft SQL is a solid choice, Access is not. So we need to get, some other things here. It is about to get better, but as is typical, before it gets better, we ran into COVID. To say that the faculty and the administrator and everybody else was not ready for this is putting it unbelievably mildly. And I'm not talking about the disease. I'm talking about no in-person classes anymore. Going to have to go to either purely online or live online. Now, there were a few of us who realized that some of our students, because I teach evening classes because most of my students work. I'm a night owl. And I've told them, if you have a 9 a.m. meeting on Friday, let me know how it goes, because I won't be there. So I had students who were working, and they couldn't always get to the classroom, but we were starting to use Zoom and WebEx. And when this happened right around spring break of 2020, we were told the pure online courses were allowed to meet, but everybody else, tell your students it's 3 weeks, and you can then do all the work you need to convert things over, and then you can start teaching. So a 3-week gap. And I'm thinking that some of those students are stuck home. They can't even work. It seems this would be a good idea to give them something to do. So as I was already doing this, I just contacted all the students, and right after spring break, we just started. The week went beautifully. Minor hiccups. I realized very quickly with Zoom, you definitely want 2 monitors, so you can have 1 monitor that you don't show to folks. And again, the students were doing fine, but word got out that I was teaching. This is a really odd thing for me, having them tell me that I did it wrong by teaching students. But it was making the other folks look bad. It's like, but okay, but the pure online courses are still meeting because, oh well. Had to tell students that week never happened. So I ended up with a couple extra weeks of vacation. It's like, use that time to get ready. Been there, done that. It was quite interesting. The other interesting part is because we lost 3 weeks, they said, okay, we'll extend the semester by 2 weeks for those folks who feel they need it. And the accountants went, everybody's saying they need it. Yeah, you just cut 3 weeks out of, some cases, an 8-week class. So, the good thing is, we, about 3 years ago, finally got approved at the state level. We had to kind of fight with some of the universities. We can now, in certain cases, offer 4-year degrees at a community college. This was a many year fight, and the one that we got was a data analytics and programming. So we started developing it around 2022-23. First classes, I think, were about fall 2023, and our first graduates should be this May. We're hoping about 40 people. We've had a lot of people interested in it. MySQL database is one of the key classes. I have at least 2 sections a semester, and they're usually full. And I also created a NoSQL class. And using MySQL, well, it was much easier on AWS Academy. So, our district was sold a Palo Alto firewall, but we also have one at MCC. The people in charge of these firewalls were not the people who knew how to configure them. So we were having problems when we were using VMware that when we tried to do updates on Linux or updates on MySQL, it would time out. And I talked to our IT person, and he proved to me, see, we're not blocking it. Yeah, but why are we getting 0 bytes per second? It's like, oh, they must be doing it at district. It took him a week to get somebody there who knew and would admit that, oh yeah, well, bzip files are only used by hackers, so we're just blocking them. And it's like, okay, can we whitelist them? It's like, yeah, give us 1 or 2. It's like, well, no, there's a big list. I need. AWS made life so much easier. I just have students install on an EC2 instance. Now, there's no Linux prereqs, so I kind of have to give them step by step for the Linux stuff. And I will go into additional information like during lab hours and the rest. But it works out pretty well. I have them create a final project in MySQL, and they have to do an entity relationship diagram, create procedures, functions, triggers, views, etc. And there's been some interesting ones. A lot of people do inventory systems. I had one person do. Dog breeding is apparently a really big thing, and he was breeding Akitas, and there's apparently breeders know each other, and they keep track of the lines. And of course, it gets a little confusing because the whole, not your relatives thing doesn't apply to dog breeding. Had a really cool system set up with it. Students have put together like Minecraft recipes so that you can search for all the components, discussion boards. Now, they don't usually have the graphical interface, but they have all the procedures and triggers to basically provide the information for that. Fitness tracking, one person created one to track You could keep track of what trails you've been on, make notes about it, and look at other people's notes and go, oh, that trail washed out this week, or hey, you should check, there's some bighorn sheep on the Fremont Saddle Trail again. I've seen them once or twice. Recipes and meal planning for the family, and quite often they create stuff to use at work. Again, we go over data types, indexes, security issues, ethics and legal issues. I demo some web interfaces, and we have separate classes, of course, and I would teach some of these where, okay, we're not going to teach you the database part, so here's a pre-built database with some procedures, but now we're going to connect that to PHP and actually have it do queries and the rest. I really like teaching the full stack. And of course, the two words that my students started to dread the most. What is the best way to do blank? Well, it depends. What are you doing? What resources do you have? What questions are you asking? There are some cases where we know there's some things that are just dumb and you shouldn't do it, but most of the time it really depends. So, some of the things that I've used. AWS EC2 is the new one. We're using MySQL 8.4 for the time being. Because we got a lot of Windows computers, we do use PuTTY and FileZilla. I still wish they didn't use PPK files, but whatever. MySQL Workbench, which is starting to become a little long in the tooth. It's no longer being updated, so when we connect it to 8.4, the students get, warning, this is not properly supplied. You want to see a student freak out? Pop up a warning. My favorite had to be in the early internet days. I had a grandma taking the class. I'm so sorry, I didn't mean to. Are they going to call the police? It's like, what? She points to the screen. You have performed an illegal operation. And I'm going, no, you didn't do anything wrong. The people who write the error messages at Windows are morons. Though she did have an odd outlook on things. I'm thinking of switching to dbeaver. We've got that installed. There is a process. I can't just install software. I have to fill out forms and wait a few weeks. I think they regret the form system because before that, I would get bounced around all the way up to the Vice Chancellor of Information Services. And then, well, okay, to be fair, he got diagnosed with stage 4 colon cancer and left, but I kept getting ignored. Now that there's an official system, they realized, oh, crud, there's a paper trail. I started getting stuff more often then. I also, of course, like portable apps. Stuff that I don't have to install really helps. Been using PyCharm for Python, but VS Code is also popular. And of course, we use Notepad++. And this semester, it's like, ooh, well, I double checked. Either we didn't install the version that was vulnerable, or because it wasn't after everybody, we were not considered important enough. And to be fair, that's happened to us before. We had a major hack in 2004. I do not know the exact details, so do not take any of this. Again, this is just what I've heard. But effectively, the FBI called us and said, hey, did you know your database is for sale online? Yeah. Of course, at the time, you had Target, Neiman Marcus, and all these other big databases. We were saved because, oh, community college students? Nobody wanted to buy it. It's like, gee, that makes me feel good. So, no SQL and MySQL. I have them install MySQL for contrast, because if you're saying it's, and I love how it's changed. It used to be no SQL, now it's not only SQL. Yeah, right, it's kind of like Pine stood for Portable Internet Network Emailer, not Pine is not Elm. We all remember what it used to say. And of course, I compare that with MongoDB, Neo4j, Cassandra, and Memcached. And I realize there are a ton of other non-relational databases out there, but I picked 4 biggies when I developed the class, and it works well. It can be a bit overwhelming. I don't think we could cover too much more. But I do use some of the JSON features to extract from a relational database to JSON and then import that into Mongo. then I'm really evil and have them try to create a database-side Mongo schema. Yeah, that's loads of fun. And of course, I discussed the document store feature in MySQL. In fact, Scott Strohs, who I think gave a talk here, he's given a talk to my NoSQL class and demonstrated the store. And it's like, wow, you can mix SQL and the JavaScript queries and a document store. And if it had the same partitioning support that Mongo did, MySQL could be a real competitor. It was kind of cool. So, students. Most of them are probably in their teens, but it ranges from about 15 to 70. Most of them are recently out of high school. Many are the first in their family to go to college. Every time at graduation, they have, how many people here are the first in your family to graduate from college? And it's about half of them or more. They vary wildly and widely in how well prepared they are. Some of them are great, some of them have never had to study before. I always love it. Can you give me extra credit? No, I don't want to grade another assignment, and I have to give it to everybody. I can't just give it to you. Why don't you just go and do the actual assignments? They will check YouTube. They'll check their friends. They'll look for books. But there's this weird person they're already paying who's sitting here in lab hours on Zoom just going, well, I had 2 people show up. Let's see what happens for the last half hour. Many of them are working full-time, often with a second job. Again, community college students have a different makeup than university students. They often have a new family or kids to care for. The number of times like, can I have a couple extra days? My wife just gave birth. It's like, yeah, no big deal. Of course, they're worried about the job market in general and the AI hype. I've had people going, and this, of course, happened just about the middle of our first 3 years of our degree. It's like, is our degree worth anything anymore? Yeah, it's going to be a little rough at first. They're going to be doing their best not to hire junior people for a while and just use senior people with AI to speed things up, is one of my guesses. But that will eventually be self-defeating because you run out of affordable or just out of entirely of the senior folks, Housing costs are climbing far faster than wages are in Arizona. And quite often employers say, oh yeah, we'll support education, and then finals week, if you don't show up, you're fired. Yeah. So students prefer live online or in person. They prefer to deal with a person. But, and this is the big but, their life just doesn't make it practical. So that's why they tend to go for the asynchronous online. I get a lot of compliments that you do it after 5, so none of my classes start till 5:20 or 7:10 to 9:15. By then, usually by about 3 o'clock, the campus is already starting to close. And at 5:20, if I have a technical support issue, yeah, oh well. At least they've stopped locking the bathrooms at 9 o'clock. I got rather upset about that. So, I do flexible attendance. Now, some of my classes are live online, which means nobody in person, but others I have a classroom, but they can attend either physically or via Zoom, and I do have some students who bounce back and forth. Of the 6 sections I teach a semester, I usually get about 1 or 2 of them where half the students show up in person. And I always have at least one of them where I'm talking to an empty room. But it really does work well. I don't require them to show their video, partly because a lot of them don't have internet that can handle that well. And they can chat their questions, they can unmute themselves and ask questions, and I always tell them, if you DM me a question, I'll read it, but I won't say your name. I have noticed, you could argue whether they're more or less prepared than they used to be. I think it's probably about the same. You just tend to notice the ones who have problems more. But as far as willingness to ask questions, I actually had a student say, well, we shouldn't interrupt you. the class is more interesting when you ask questions. So the DM thing seems to help. Again, we do it for time. And I will do step-by-step lab assignments where we'll work our way through class. And then I will have students add on, like you'll create a simple little table here, and then I want you to alter the table, add a few columns, put your name in it with some inserts and updates and other things, and then do a screenshot of that. And the fact that they have to put their information in it means it's more likely that they're going to do it and not necessarily be just a copy of somebody else's homework. Though with the way generative AI is, they could probably fake this. We'll see. I create a large number of help pages that I constantly update and tailor to the students' needs. And sometimes I beg some students. I have 3 types of students, basically, when it comes to lab hours. Those who always show up and don't really need it, but it's still good to see them, and they ask some cool questions. Those folks who do need it, and they come occasionally, and they do much better. And then those who desperately need it, and I never see them, no matter how much I beg or plead. And of course, I also have speakers come in, and David Stokes was one of the first ones from Oracle at the time who gave talks to my database classes via Zoom. And Scott Strohs has done a couple, and I'll probably have him come via Zoom this April as well. So I do help pages, and I gotta admit, I always told my web students, everything I teach you is great, just ignore how I pick color. And no, I've been tested, I'm not colorblind, so I don't have that excuse. I tend to use too much color. I actually did use a palette generator, but I don't know how to be subtle. But I do use a little Python script that does the color coding on the code. And we get to this point. I am mostly self-taught. I just started playing around and building my own servers and compiling kernels for no good reason. I updated the cache on my little 486, which I have no idea if it did any good, and just, learn that way. I'm constantly trying to keep up on all the different technologies, and we'll get to the whole AI issue here in a minute. I go to conferences, and it's mostly to get a list of things I need to learn or a list of things I shouldn't do anymore. I've gotten those. One of my favorites was we have a local security conference called Cactus Con, and I'm walking by, and somebody says, oh yeah, if you're using Jinja 2 templates in Flask, there's this huge injection vulnerability. It's like, hello, I need to talk to you right now because I use that. I've been to SCaLE, DEF CON a few times, Percona Live. I wish they would do that one again. That was a great one. And that was back when David Stokes worked for Percona. And of course, PyCon. This year, I can't go to PyCon. It's actually closer. Instead of Pittsburgh, it's in LA. But it's the weekend of finals, and it's graduation, and it's our first batch of students. And they've all had me as a teacher, so I need to show up. We've been hiring some people. I'm on the interview committee. I see these folks, and I go, whew, I'm glad my job is secure, because these people are really good, and I feel inadequate. And of course, we have things like AI. So, future of education, AI. Hype versus reality. It is going to do everything. It is going to destroy everything. It's absolutely worthless. It's the best thing ever. And I'm fairly certain both of those groups are entirely wrong. It's going to be muddle out in the middle. There are certain cases where it works really well. And it's getting better. But it's also quite clear what happens when people are using it in an area they're not familiar with. There are some folks who've done some amazing projects with Python and other things using Claude and other tools, but they take their time to figure out what it is that just spit it to it. Some of them are great at explaining what's going on. It's a big deal. And some students are using it, and some of them are really bad about it. Python, my intro Python class, where they've never done any programming, that's where I get most of it. And it's usually from some library that doesn't exist, import something that's not even used in the code. And I try to run it and it just dies. Now there is a new attack based on this. Has anybody heard of slop squatting? That's where some of the folks who create bad libraries notice that these AIs tend to generate the same bad name, so they create actual libraries of that name to trick people to installing an attack library. Yeah, I usually just go, I don't know if this is AI slop or not, but this is not the assignment. Please see me in lab and let's redo it. For now, you get a 0. To say that schools and colleges are still trying to work out AI policies is putting it mildly. I'm trying to convince them that they need to learn the material and then use AI to speed up their productivity. But nobody wants to take those first steps. Well, there's a certain number of students who don't want to take those first steps. And of course, because of this, students are incredibly worried about the job market, because the people who are trying to sell you things, NVIDIA, Anthropic, and OpenAI, oh yeah, you can get rid of all your employees. You won't need anybody. You know, you can have the janitor for half price code your whole code base. It's what it sounds like. And to the students, they hear this, it's like, it's already a competitive job market, and they're not going to want a beginner like me. And I give them a variety of advice. Pick a couple projects, work on them, put them up on GitHub, and just tinker. We've got various different data sources, Kaggle, we have access to Policy Map. Do a data project and show that you're using Python and then maybe Tableau or Power BI or KNIME, maybe some R, and then presenting it with a database and just show them that you're working on things. That's going to be useful as well. But it's no guarantee. And I'll be honest, I'm not entirely sure what to tell them. And yet, you know, as I was mentioning, some of the projects they do are really, really cool. And I have honors projects in most of my classes where a couple students will come in, we'll set up a project, I give them some ideas, they go through it, and I, in many cases, learn more than the student. One, we're doing a demo table at the Barrett-Jackson STEM show, which is the one family day for this huge car show in the Valley. I mean, some of these cars, I've only ever once seen a price on one. It was a really fancy SUV, and it started at $500,000. I mean, these are really nice custom things. So I had a student who, for his honors project, now he did use, I think, Claude for some of the JavaScript front end, but for the back end for Neo4j and a few other things, he took the map of the school, created a whole bunch of different little nodes, and you could pick any 2 spots and it would give you walking directions to get there. And he demonstrated that. That was a really cool thing. So, you know, we're being pushed, put AI in every class. Well, I mean, I at least discuss it, and I do demonstrate, you know, building tables with ChatGPT or others, and point out, you know, like any tool, you have to double check it. But it is, I don't know how to put it. I don't know what to tell them sometimes. Hell, a lot of the faculty don't know. We do have folks who say things like, oh yes, and my thought partner. Oh well, I won't say which of our administrators said that, but it made me cringe. And yet, I mean, you've all played with it. Some of you build it, some of you work with it. It can do incredible things. It can also do a big pile of male bovine excrement. If you can give me any advice, but I'm hoping just the history of how I dealt with open source and tried to be an advocate for it was at least somewhat interesting. Any questions? I mean, I could try.
Does anyone have any questions?
Oh, hello. Yeah, hi. My name's Ian. I'm a student at Cal Poly Pomona, and I'm part of my school's cybersecurity club. I really like putting together the workshops for the club and teaching the other students, but I'm about to graduate with a bachelor's, so do you know if there's any other type of opportunities someone in my position could continue teaching people like cyber IT stuff with after graduation without getting a master's, or am I gonna have to get one maybe?
So you're looking for teaching opportunities before you have like a master's or other upper level degree.
Yeah.
It really depends on the school and where you're going. You can become an adjunct. Understand that adjunct means underpaid for what you do. But it is a good way to get experience. Sometimes you may not be required to do that. You can also use work experience if you have that. I was occupationally certified. My actual degrees are in a STEM field. They're just not in computer information. But I worked at a few places and basically babysat networks at night and other things like that. That's one possibility. You might want to look at, there are online places that will let you teach or develop classes. You could just try to do it with some local groups. Look at some of the LUGs, the Linux user groups. Quite often you can do presentations and put those up on YouTube. It can help. You have to kind of get your name out there. The degrees are important, and they'll usually get you the job, but you won't know the job exists quite often unless you do some networking. I mean, yeah, they'll put stuff on LinkedIn, they'll put it on the other job searches, but like even for the Phoenix Linux Users Group, a lot of those people work at different companies throughout the valley. And they will occasionally, somebody's been coming to the meetings, they've been asking cool questions, they're not somebody you want to kill in 2 weeks, and they'll go, hey, we've got a potential position open, you should apply for it. And you won't normally hear that, because that's one of the drawbacks of using places like LinkedIn and other tools, is you may get somebody who's brilliant, but you're going to have to figure out where to hide the body in 2 weeks, because nobody can stand them. And that is definitely a skill that a lot of people in the computer field need to learn. So, again, I wish I had better answers, but that's some possibilities.
Thank you so much.
Yeah.
Anyone else?
Hi, I was just wondering, what was your experience building the curriculum and the lesson plan for the MySQL class?
Building the curriculum for the NoSQL class.
MySQL, the main one. What are the experiences that kind of shaped it, or?
We have two levels of curriculum development. There's the official competencies that are put into the course bank, and then there's the actual material. The material in MySQL has evolved over time. I keep adding new pages, new things that we find, and of course some of the changes. Going from 5.7 to 8 was actually, even when 5.7 kicked in and suddenly, you need a separate permission for references and little things like that. It can be a pain. You have to constantly keep it up to date. But the NoSQL one, I've done both levels. So the MySQL curriculum was developed, and then I built the class materials. But NoSQL, it was me from the beginning. And this was a team, as we're building it for a 4-year degree, even though it's a 200-level class. We had people from several other colleges who were giving feedback, and I put the course together because it was the one I was supposed to write, and I'm sitting here looking at this going, whew, may have been a little ambitious. So when I bring it forward to them, I say, okay, feel free to cut some stuff out. I may have been a little bit overly ambitious. I'm worried that this might be a little bit too much to try to do in a single semester class. They deleted a line, changed some wording, added one other line, and said, it's good to go. And I'm sitting here going, oh no, now I have to teach it. And that one took, I would say, about the 3rd time I taught it, it was finally fleshed out. You're allowed to do a pilot. I technically did 2 pilots. And then I got a lot of things worked out, and I'm at the point where I'm not adding too much in the way of new material. The last big thing I did was adding the server-side schemas in MongoDB, which you can definitely tell that that was not the original intent behind Mongo. People would normally enforce schemas on the front end using something like Mongoose.js. You could do it on the server side. It definitely slows things down. That's usually when a student, first time they put in a schema in Mongo, is when they realize they put in a T3 micro instead of a T2 medium because things slow way down. It's like, yeah, there's a reason why I said not to use the default itty-bitty little instance. So, I mean, that's part of it. I go to conferences, I go to these talks, I'm already thinking about dbeaver, and I'm looking at the AI options, and it's like, well, you know, helping them learn about that and not just do it for them, that might be a useful tool. So that could be something I could add in. We are constantly updating things, partly because software changes, partly because things become out of date, and occasionally it's because, ooh, this is cool, I want to show them. I don't know if, again, I hope I answered your question. I'm a little tired, so.
No, it was perfect. Thank you for your presentation and for doing all this work for community college students. I went to a community college before I got my undergrad degree, so it's always something I like to see.
I like to think that we give a really good bang for the buck. I mean, yes, there's the occasional class that just goes kablooey, and there's the occasional instructor that will eventually need to be encouraged to seek other pastures. But overall, I think we do a pretty good job. We have folks from ASU come back for us because we have programming classes where you program and build things. I got a compliment from one of the folks who works for the chief CISO, Chief Information Security Officer at ASU. My friend said, yeah, half the folks in our department took a class with Phil. And I don't know if that's true or not, but it feels really good.
Anyone else? No? Let's give a round of applause for Phil. Thank you so much, Phil.